what you are holding. And I want to assure you that because I'm doing the teaching and it's online, that is why I prepared the slides. Okay, the slides are because of you, to simplify the material I have. Okay, because it's a lot of material, and I wanted to make sure that all of you have at least understand me when I'm talking, because I'll be talking through the material, and I wanted all of you to follow me as I talk through the material. That is why I was using the slides, but you all have the same material. Okay, if you are holding this book, or if you have this book on your phone or on your laptop, you are safe. You have the same book everybody around the country is using to follow this course. Okay, so please don't be disturbed, or don't think that we are using something different. Okay.
Okay, sir.
Unless you have a different book, or you received something different from Code. Okay, but if you received the same book, then we are using the same book, right? I've had countless people send me text messages asking for slides and slides. The reason why I'm not giving the slides is because I want us all to use the same book for the learning. Okay, the slides are my presentation materials, and I simplify the material so that I can teach the material. Okay, so please use this book. Okay. Hello.
Yes, sir.
Okay, so we all agree we have this book. Okay. If we all agree we have that book, then I think we are on the same page. Okay. So we will use this book, and from now on, I will just use the material in this book. I will not bring my slides here. I want us all to stick with this book so that we can all do the learning the same on the campus and the same on online as well. Okay. Okay, so we are currently on Unit 3. Today I'll do Unit 3 and Unit 4. Okay, then next week is, I think, our final face-to-face. I'll do 5 and 6. Okay, so I'll be in a little bit of a rush, but prompt me if you have any issues. Okay, so I'll take a pencil. Okay, so we are going to look at Unit 3. And under Unit 3, we are supposed to look at decision control structures. Okay, so in programming, we have 3 decision control structures. Okay, sorry, we have 3 control structures. We have sequential control structures, we have decision control structures, and then we have loop control structures. If you are following the material we are using in the book, you realize that we have spoken about this in the previous section. Okay, and once you have read that previous section, we hope that you are at least up to date with what we are going to discuss over here. So what is decision control structures? In programming, when we say decision control structures, we are basically talking about a sequence of instructions or code which are used to make decisions. Okay, so we as human beings make decisions. We decide on whether something is true or false, whether something is valid or invalid. Now, same applies with the computer, or same applies in programming. In programming, we have control structures which can allow our programming to appear as though it is intelligent. Okay, And how does it appear as though it is intelligent? It can make decision and decide on whether a statement is true or false. So at the end of this lecture, we are going to learn about what conditional statements are. Okay, we want to learn about what conditional statements are. We want to learn about the if statement, right? There's a statement called the if statement. We also want to learn about the if else statement, right? We also want to learn about switch case statements, okay, which are also a type of decision control structures. And then we also want to learn about how to write those things, right? Because it's a major part of your exam. Okay, you need to understand how these things work in the programming. Okay, then we want to use them in real life. Okay, so let's proceed, and then now I will demonstrate, or I will explain to you what the example in the book is talking about. Now, when we for example, when we are asked as programmers to design maybe a program to maybe decide whether somebody is maybe somebody's age is greater than or equal to 18 years. Okay, we want to decide whether someone's age is greater than or equal to 18 years. Okay. Okay. Oops. Yes. Okay. Okay. Let me take these ones out of here. Okay. Okay. And then let's take a pencil again. And then, for example, if we have a variable called age, okay, we want to check whether age is greater than or equal to 18, right? Now, if, for example, I come and my age is 12 years old, everybody knows that the answer, if my age is equal to 12 years old, then when we ask the question, is your age greater than or, oh, sorry, I made a mistake with that one. Yikes. Let me change the pencil. Let me change the, okay. Okay, so if I come and I ask a question, okay, is my age, since my age is 12 years, is age greater than or equal to 18 years? Most of you are going to say that, oh, because the age is 12 years, then my age is not greater than or equal to 18. And so the answer to this question is what? False. Do you agree?
Yes, sir.
Yes, sir.
Okay. I hope most of you understand what is going on. Yes. So because the age variable contains a value which is 12 years or 12, therefore, if we ask the question, is age greater than or equal to 18 years, you are going to reply as what? False. But should we have, let me clean that. Should we have maybe put the value maybe 21 inside the variable age, and we ask the question, is age greater than or equal to 18? Because age is 21 and 21 is greater than 18, most of you will reply as what? True. Is that okay? Do you understand what I'm trying to explain?
Yes, sir.
Okay, so I say that thumbs up means that you understand. Okay, so this kind of questions or this kind of reasoning is what we call conditional statements. We call them conditional statements. What they mean is that we can ask a question and then the response will be either true or false. Okay, we can ask a question and then the response or the answer to that particular question we ask is either true or false. Okay, so that type of reasoning is called conditional statements. And in programming, there's the structure that allows us to do conditional statements is a structure we call the if, else, or if statements. Okay, so in this particular lecture, we are learning about the if statements. Okay, now further down our material, we also will learn about something called the switch case. Okay, so I'll show you how to write the if statement, which is one of the fundamental statements in programming for writing conditional statements. Okay, so we have the if statement. Then you can add something called the else to the if. Okay, then in some cases you can do what we call a switch case. So you can see the switch case over here as well. Okay, so I'm going to show you how to combine those statements and generate the proper responses when we compare if else. Okay, please note that this is very important to succeeding or passing this course. So please pay particular attention to how I help you to understand the reasoning behind if else statements. Okay. Okay, so let's proceed now. In programming, in most programming languages, the syntax for writing the if else statement, or the syntax for writing an if statement, is what you see in the what do you call it, in the green box. Okay, so you need to write the if, and then you put in to the bracket something called a condition. The condition is a logical statement, which is a question of a sort. Now, the condition can only be written using one of the 6 logical operators. So we have greater than or equal to, or less than or equal to, right? Or we have the not equal to. Okay, do you remember that one? And then we have the equal to. We discussed that last week. Okay, the mathematical expressions. So these 6 operators are what we use inside the conditional statement. Okay, so you must write the statement so that over there, your statement is asking a question, which is either true or false. An example is what I gave earlier of the age. Okay, so we ask a question. Is the person, or are you 18 years? Is age 18 years?
Yeah.
Or is age greater than or equal to 18 years? If age is greater than or equal to 18 years, then maybe we let you vote. Or we say that you are eligible, you are not eligible to vote. Okay, so if we write or we draw the logical expression, we will come up with something like this. Okay, this is called a flow chart. Okay, flow chart. And this flow chart is a graphical depiction of the statement we see inside the green box. So you will normally see that inside that green box, you will see the if, and then you see the condition. Now in the flow chart, we put the condition inside the kite. We call that shape a kite, or we call the shape a diamond. Okay, so we put that condition over here inside the diamond. So if age is greater than or equal to 18, then if that is the case, then we come and do the condition down here. Okay, so if the condition is true, then we come and do the statement in the box over here. So let me use a different color. So the statement in the box over here is only done when the condition is true. Okay, but if the condition is not true, then it means you are going to take the line over here, which means that if the statement is not true, you will not do anything inside the yellow box. Do you understand that? So you only do what is inside the yellow box if the statement is true. But if the statement is not true, then you pass where the red line is. It means we are not going to do anything inside the yellow box. So that is the logical understanding of the if statement. We call this kind of construction a single if statement. Are you okay? Okay, so I take it that we all understand what's going on. Okay. Okay. Let me take out the. Okay. Now there's an example down there I want us to have a look at. Okay. So when we look at this example over here, okay, it's similar to what I wrote earlier. Now, if we look at this example, we see that we have a variable called age. That variable contains the number 25. So the variable called age contains 25, which you see over here. Then we are checking, is 25 or is the number 25, is it greater than or equal to 18? So if 25 is greater than or equal to 18, then we want to say that you are an adult. Okay, so you see that logic? We ask a question. The logic is that we are asking a question. Is your age greater than or equal to 25? If your age is greater than or equal to 25, then you should pass here, do that one, and go down here. Okay? We only do that one if your age is greater than 25. But if your age is not greater than 25, then it means that answer is false. And so you should pass here and then go down here. I hope you're understanding the logic for this particular program. Okay? Gosh. Come back to the original pages. Sorry. Okay. So, okay. 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 So, that is the logic for this particular program that we are seeing over here. Okay.
Sir, my hand is up.
Pardon?
I have a question or a suggestion. Please,
okay, sir.
With the model that I have over here, it says if the condition is true, then you are going to pass through the side. It is opposite from what you are saying.
Sorry, I don't understand. You said what?
Please, on your model, the one you are projecting now. The if condition is false, with the one that I have over here, that is if the condition is true. I don't know if other people do understand.
I'm not understanding what you are asking.
The diagram you are showing to us now.
Please, meet your mic, giving us a feedback.
Is it okay now?
Yeah, it is.
Yeah, I am saying that with what Sir is projecting now, it is opposite from what we have in the slide. I don't know if other people too have noticed that. Where says on says, if the condition is false, the one I have over here is saying if the condition is true, you don't pass through the else code. I don't know if somebody too have noticed that.
Okay, you mean to say that I'm showing you something which is false?
Yes, where yours is saying if the condition is false, the one I have over here is saying if the condition is true.
Oh,
then I think it's your document, because what I have here is in line with what say is having.
Wow.
I'm totally lost.
Sir, the one thing is that maybe he has opened the else
He's the one,
condition.
he's the one. Listen, there is two paragraphs in it. He is at the second one.
Yes, the other one is else statement.
We are the
The
first
else
one to take it to.
statement is
Okay. Noted.
He has gone ahead of that.
You have gone to the second one. You are the first one.
Okay.
So just check the
Thank
first
you.
one.
Yeah, we are still at the if, the first one, the if.
I've seen it now.
So the else statement is different from the if statement.
All right. Thank you.
Serious. Please, look at what I'm doing, okay? I don't know what in fact, I was not understanding anything of what you were saying, because I can see true, but you are saying I'm saying false. I don't understand.
He went ahead of you with the slide.
Oh, serious.
There's another flow chart that
Please
follows
calm yourself, okay, and follow us, okay? Calm yourself and follow us, okay. So then somebody will say, what happens if we want to do something when it is false? Okay, what happens? How do we do something when it is false? Okay, so they came up with something very ingenious. What they came up with is that we will just adjust the if statement and add a small statement called the else. Okay, so we will just rewrite the if statement by writing an else over there. Okay, now what happens with this statement is that it still works like the same way it used to work, but this time around it will work a little bit better. How is this different from the first one? It is different because here we only do this statement when the answer is true. Okay, so when the answer is true, that is the only time that we do the first statement up there. But when the answer is false, then we go and do the else statement. So when the answer to the question is false, then we go and do the else statement. Okay, so the whole thing now reads if condition, then we do the first statement, else we come and do the second statement. Okay, and you see that the only difference between the two of them is that this time around with the first one there was nothing on the else, but now if you look at the flow chart, there is a box on the else. Oh, sorry, that's not a great place. Okay, so there's a box on the else. Okay, so we do this one when it is what? False, and then we go and do this one when it is true. Is this where the guy saw and he was saying my own is saying false and his own is saying true?
Yes, sir.
Oh, my dear friend. Open your eyes. Okay, so you can clearly see that it is saying true over here. Okay, and then you can see, sorry for the so you can also see that it is saying false over here. Okay, so please watch the writing. Okay, watch the writing. So we ask a question. When the answer to the question is true, we go and do the first part of the if statement. But when the answer to the question is false, we go and do the second part of the else statement, okay? Or the second part of the if statement, sorry. Okay, so here, instead of just doing one thing when it is true, here we can do two things. One when it is true and another when it is okay. Let me wipe this and then let's see an example that we have in the document. Okay, so let's look at this example. I'm maximizing it so we can all see it well. Okay, so in this small example, we are still working with the age example. Okay, we set age to 15. And then we ask a question. Oh, if age is greater than or equal to 18. So we know that if it is true, we do this one. And we also know that based on what we have studied, if it is false, we do this one. Okay, so with those two examples, sorry, keep going back to that first page. Yes.
Hello, sir.
Yes.
I was saying that as you're using mobile phone, if you can turn it or rotate it for us so that it will be wide.
Oh, okay. I'll try and do that.
Yeah, like landscape.
Yes.
Thank
okay,
you,
is that okay? Okay. Is it better?
Yes, sir. It's now okay. It's okay.
Thank you. Thank you.
Thank you, sir. Yes, sir.
Okay, so we see that we only do the first part when it is true, and then we only do the second part when it is false. So here in this example, when age is equal to 15, which one will we see on the screen? Will we see you are an adult, or will you see you are a minor based on the number 15?
Sir, I think you are a minor.
Thank you very much. That's very correct. You are going to see you are a minor. Okay. Thank you. Okay. So let's proceed. Okay. Okay. So then we also learned that the if statements are not the only statements for making decisions in programming. There's another statement, a third statement. We call it the switch case statement. Okay, so how does it work? This one, unlike the if statement, where we are doing a form of comparison, okay, over here, with the switch case, we do not do any of that comparison. Instead, with the switch case, we pick an expression. Okay, we pick an expression, and then we test whether the value of the expression is equal to any of these values. Okay, we can have more. If it is not equal to any of those values, then we come and do what we call the default. Are you with me? Okay, thank you very much for acknowledging that. Okay, so the switch case is also another form of decision making. Okay, in programming, you can either do if else, or you can do switch. Okay, with the switch, we test a particular expression. The switch does not test conditionals. It doesn't test whether something is true or false. No. As for the switch, it tests whether the thing you are holding in the variable is equal to any of the values I am holding. That is what we call an expression. Okay, so the switch has to evaluate to a number. Okay, a number, a whole number, or a value like A, B, C, D, a character. Okay, the switch cannot be someone's name. Okay, you cannot switch on a name, string, decimals, or those kinds of things. We advise you not to do that in switch. But instead, when you want to use switch, you use it for numbers. Okay, whole numbers or characters. All right, because it's a very simple statement which can be used for that purpose. Okay. Now let's look at an example, or let's look at the flow chart, and then I'll show you an example. So the flow chart for the switch case looks like this. It's also similar, but you can see that we are checking various cases. So we'll have the expression in the diamond. Okay, then we will check, okay, is the expression equal to case 1? If it is equal to case 1, we pass here, do what is in block 1 and go. But if it is not equal to what is in case 1 and is equal to what is in case 2, we pass here, do what is inside block 2 and go. But if it is not equal to what is inside block 2, then we can check, is it equal to what is inside block 3? We pass here, do what is inside block 3 and go. So notice that with the switch case, we are just checking what is inside the expression. If it matches any of the cases, we run the particular code that is in the cases and then we exit. Okay. Now, if we cannot find what we are looking for, then you can add a default. And what the default is that if none of the answers are true, then we'll just do the default and then we exit. Okay, so the default is done when none of the answers are true. Okay, so let me proceed. Okay, let's do the example. So we're looking at the example for the switch case. So in this simple example, we see the switch case being used to check the days of the week. So we have a variable called day, and we set day equal to Wednesday. Now, what we want to do is to check whether the switch, when we switch on a particular variable, which is D, means Thursday or any of the other dates. Okay. Okay, so we check, okay, is the value inside the variable day, is it equal to Monday? we know that that is not equal to Monday. So we don't do that one. Okay. Then we check. Is the value inside Wednesday, is it equal to what is in, is it equal to Tuesday? Then we don't do that one as well. Okay. Then we check, is the value that is inside day, is it equal to Wednesday? Now, because it's equal to Wednesday, we know that that is the correct answer. Okay, so because that's the correct answer, we will print it's hump day. Okay, now you notice that there is a small statement in each of those statements. If you've looked at it carefully, it's break. You can see break over here, you can see break over here. I will explain what break does. So what break is that if we find the answer and we run the statements and we get to the break will force us to stop and go outside that particular switch case. Okay, so brake is just like how your car brake works. If you are moving and you hit the brake, you stop. Okay, so that's the same way that brake works. So we will find the correct answer. We will print hump day. Then when we see brake, we will stop and then go out. If we don't see brake, we will keep doing what is down there. Okay, so should an example is that should we maybe if we didn't have the break over here and the answer was Wednesday and we found out that, oh, the correct case is Wednesday, then we printed it's hump day. Because there is no break between Wednesday and Thursday, the program will not stop, but it will continue and print it is almost Friday, in addition to printing the correct answer. Do you understand what that is? Okay, so the break is there to prevent the computer from continuing down there. Okay, if you put the break there, the computer will stop when it finds the correct answer. Okay. If you have any questions, kindly draw my attention so that I can address it for you. Okay. Okay, so the break is there so that if the computer finds the correct answer, it will stop over there and not continue with the rest of the code. Okay, I think, okay, there's more examples. Okay, so they explain what each of the words in there mean. I've already explained that. I've already explained what each of the words there mean, right? So the various cases are what you are comparing against, and then the break statement stops the program, right? Over here, we say we terminate the program, okay, or terminate execution of the program, okay? Then file is executed when we can't find an answer. Okay, so if there are, if for example, none of the answers is equal to what you chose. For example, if we chose maybe if it was not Wednesday, but instead it was what day is not here? Maybe Sunday. We see that Sunday, okay? So let's say day contains Sunday, okay? And after checking all of the answers, Sunday was not there. Because of the default, we will come and write enjoy your day, even though Sunday is not there. Because there's a default, we'll come and write that print statement down there. Okay, the default is done when we can't find an answer. Are we okay? Okay. Okay. I'm glad you understand it. Okay, that's good. Okay. To the next section. Okay. Then the next section discusses another important part of your programming, which is another control structure we call the loop control structure. Okay, so what the loop control structure is that, you see, as the sequential statements allow you to do one statement, yes, sir.
Hello, sir. Sir, is it your audio is
Okay.
off? We
Can
can't
you hear me now?
Yes, we can hear
Sir.
you, sir.
Okay, okay. Thank you. Thank you. Okay, so I was just, what I was saying that we lost the connection was that there are three control structures. Like I said, the sequential statements run the statements one after another. The loop, sorry, the selection statements or the decision statements make decisions between what is true or false. Then what the loop control structures do, or the loop statements do, is that they allow you to repeat something several times. Okay, so the loop control structures allow you to repeat instead of writing the thing several times. For example, I want to say hello world 5 times. I can decide to write it hello world 1, hello world 2, hello world 3, hello world 4, hello world 5. Most of you have no problem with this, okay? Because you can write. It is very simple. But what if you want to write it 5 million times? You can't keep writing hello world 5 million times. Even if you are copying and pasting, you make mistakes. It's either you will get less than 5 million or you get more than 5 million. You can't count 5 million times of hello world. Okay? So there's a problem. You cannot keep rewriting the statements that you want to repeat. So there are control structures that allow you to repeat the statements without rewriting it. Okay? These are the statements we call loop control statements or loop control structure. Okay? There are primarily 3 of them in programming. Okay? We have the for loop, we have the while loop, and then we have the do while loop. I repeat again, we have the for loop, we have the while loop, and then we have the do while loop. Let me explain. So with the for loop, what is happening is that we want to use the structure to repeat some statements for a specific number of times. So for example, I asked you to mention my name 5 times. Before you even start mentioning my name, you know exactly how many times I have asked you to mention my name. Okay? So when you know exactly how many times you want to do something, you are always going to use the for loop. The for loop is used when we know exactly how many times you want to do something, right? So we call the for loop a kind of counter control loop, because we know exactly how many times we want to do something. Okay? Now, how do we write a for loop? There is a syntax or a basic structure. Okay? So with the for loop, this is the syntax. Okay? This is the syntax. So first and foremost, of course, you write the for. Then you put the bracket there. Then inside the bracket, there are 3 things you need for the for loop. Number 1, you need something called the initialization statement. Okay? Usually the initialization statement is a variable we are using for counting. Because you know how many times you want to do the thing, you will use something called a counter. So you need to create the counter and start the counting. Okay, so in programming, we will create a variable, which is usually an integer, and then we will set it equal to either 0 or 1, or a particular value that we want to start counting from. Okay, please don't use decimals. In programming, we don't count in decimals. We usually count in integers. Okay. Then the second part of the for loop uses something we call a test expression. Where do you want to stop the count? So maybe you want to count from 0 to 9, or want to count from, maybe if we are repeating something 5 times and we start from 0, we will stop at 4, because 0 is counted in programming. Okay, so 0, 1, 2, 3, and 4. Those are 5 numbers. Okay, so we will need a way to stop the loop when we get to the number that we want. Okay, we call that one the test expression. Can you hear me? Okay. Then the final part of what's in the bracket is called the update. So this one tells the computer how to advance the count. Okay, so for example, I want to count 5 times. Every time I count, I want to increase the number by 1. Okay, so that is where you put how the number should be increased or how the number should be reduced. Okay, so the 3 things are the initialization. You create the counter. The test, you tell the computer where to stop the count. And then the update is you tell the computer how to advance or reduce the counting. Then when you are done with those 3 things, the most important thing, of course, are the statements that you want to use. So you put those statements inside the loop. Okay, so for example, I want to print Bernard 5 times. So I will write that statement, print Bernard. I'll write it only once inside that yellow box. And then I just need to write the statements at the green, the blue, and the red places well. Once I write them well, it will repeat the yellow box 5 times. We'll see an example very soon. There's a hand by Mr. Raphael. Please go on.
Yes, sir. Please, I want to know if the text expression can also be called a condition.
Oh, yes. So this one, it can also be called condition. Okay. Hello. Okay. So I take it that he heard me. Okay. So it can also be called a condition. Okay. Because it's a Boolean expression. It evaluates to true or false. Okay. It's a Boolean expression. It evaluates to true or false. Okay. So let's look at an example, and then we will we will better understand it, and we go on. So before the example, I think that there's a flow chart which also explains what is going on. So I'll show you I will discuss the example with you, and then I'll use the flow chart to discuss the example. Okay, so let's look at this example. So we have this example of a for loop. I'll mark the various parts. So the first part we see is the initialization. So we create a counter variable called I. Okay, so I is going to be used for counting, but because it's going to be used for counting and it's programming, we must tell the computer where to start the count. So here we are telling the computer that, oh, start the counting from 1. Are you with me? Then the second part of the for loop is telling the computer where to stop the count. So we will keep counting when I is less than 11. So it means the last number will be what? Will be 10. Okay, so I is 1, but we will allow it to count when I is less than 11. Remember, 1 is less than 11, 2 is less than 11, 3 is less than 11, 4 is less than 11, 5 is less than 11, 6 is less than 11, 7 is less than 11, 8 is less than 11, 9 is less than 11, 10 is less than 11, but 11 is not less than 11. I hope you all agree. Then we also see that, okay, now how do we advance the count? How do we tell the computer that, oh, when you are counting, move? How do we move? Do we move +2 +2 +2 or +1 +1 or what? So here we are telling the computer every time you count, add 1. Okay, so the first time we check I is equal to 1. Then we check is 1 less than 11? Because it is true, we come and print 1. So we print 1. Then we add 1. So we get what? 2. And then we check is 2 less than 11? So we come and print 2. Then we add 1, we get 3. Is 3 less than 11? We come and print 3. We add 1, we get 4. Is 4 less than 11? So we keep doing it until we get to a number which is not less than 11. And then once we get to that number, for example, 11, which is not less than 11, then we stop the count. Are you okay? Okay, thank you. Thank you very much. Please, if you have any questions, you interrupt us so that you can. I need you to understand this part very well. It's also key for your exams. Okay, these ones are very important for future understanding of programming. Okay.
Sir, I have a question.
Okay, I'm listening.
The part where you wrote the ++I, where the red was underlined. We set the value of I to be 1. So if maybe though, please, can you hear me?
Yes, I can hear.
Okay, so we know the value of I is 1, and we want to count by 1. That is why we did ++I. So if the value of I is still 1, but we want to count by 2, we can write ++2. Are we supposed to do that?
No.
Okay.
I'll show you. So you just write I is equal. Oh, sorry. I pick a pencil. Okay. You just write I is equal to I plus 2. Okay. Is it? Oh, that's terrible. Okay. But can you get the idea? Do you get the idea?
So instead of the ++1, we rather write I is equal to I plus 2.
Yes.
To indicate the pattern of counting.
Yes. Because
okay,
I told you ++, we learned it last week, right?
Yes, that one has to
it's
do
a short,
with
it's a short
adding
for
1.
writing I equal I plus 1.
Plus 1, yes.
So it's just a shorthand. It's just a shorthand. It's not anything.
Sir.
Yes.
Can you also say I plus equal to 2?
Come again.
I say, can you also say I plus equal to 2?
Yes.
Okay, thank you, sir.
For those of you who are lost, We learned all of this last week. It's in the book. It's a shorthand notation in the programming. Okay. So if you write I plus equal to 2, it means I equal I plus 2. Okay, it's shorthand in the programming. Okay, so that plus I is also shorthand. Okay, thank you very much. Okay. So let's proceed. So there's some explanation to help you understand what, but I basically explained everything. Then when we said that the for loop is used when you know the number of times. What if you don't know the number of times? So that case, we do something we call a sentinel. Okay, what a sentinel is that if you don't know how many times you want to repeat something, hello. Okay. Okay, thank you.
Hello, sir.
So if you don't know how many times you want to repeat something, then what you can do is that you can, instead of counting to a particular number, you can let the program continue counting until you tell it a specific thing. So for example, if I wanted to count 5 times, I have told you exactly how many times. You use a for loop. But what if I wanted to count until you reach a specific, or I enter a specific number? So maybe count until someone enters 0. So it means until someone comes to that computer program and enters 0, the computer will still continue counting. Maybe it will print hello Bernard, hello Bernard, hello Bernard, hello Bernard, hello Bernard. It will keep on saying hello Bernard until someone enters 0. Okay, let me take a question from the, what is that? Michael Righteous?
Yes, sir. Sir, good evening. Sir, good evening.
Good evening.
Hello, sir. Yeah, please, about the while loop, as you're explaining, I think my brother asked a question. If only you just break it down small, because as I say, we are getting lost over there.
Brother is what? Hello? Did someone get what he said? Okay, there's another hand. Eric?
Hello, sir.
Yes, sir.
Please, I'm just reminding you that when we're doing the for loop, you said you would demonstrate with a flow chart, but it seems you skipped that.
Oh, dear sir, I'm following your book. Do you see the example in the book? Are you seeing the screen?
Yes, sir. I'm seeing
So you see the flow chart.
You told us.
Yes, but if I tell you something and it's we are using the book. Come on, my dear friends.
You said after explaining, you would use this to also explain. So I was just reminding you. I was thinking maybe escape you.
Okay, it escaped me. I thought you were following. So I'm gonna help that. Okay. So,
Okay, thank
so
you,
from
teacher.
the flow chart over here, let me show you the various parts, okay? Then we'll quickly go to the while loop, okay? My dear friend, I'll come back to you with the while loop, okay? So with the for loop, you can see that from the flow chart, this part is, oh, sorry. So this part of the loop is this part, okay? That's the part we create the variable. So we are creating the variable, okay? Then we are setting the initial value of the variable. So we do that inside the diamond, okay? Then we also checking when to stop. So that one too is done inside the diamond. Then the part which is updating is done inside the body of the diamond, okay? The body of the loop. Then the loop body itself or the statement itself is done here, okay? So what happens is that when we set these things, we come and do the check. If the answer is true, we come and run the body, then we update, then we go back and ask the question, okay? If the answer to the question is still true, we come and repeat these things. So in the end, you get something like a loop, okay? You get a loop, something that goes around and comes back to the same place, which is the diamond, okay? And so that is what we refer to as a loop, because it goes around and comes back to the same question. It will keep repeating until it gets to a number which is what? Greater than which is not less than 11, okay? So that is what we mean by that. But there's no other loop. Sorry, there's no other flow chart here to use to explain to you. I'm sorry, okay? If I brought my slide, then probably I would use the slide, okay?
Sir. Hello, sir.
Yes, sir.
With the initialization, can't you initialize it inside the for?
Oh, you can do that. You can
yes,
do that.
like,
There are countless
for
examples. I think you have
equal to
seen some
1.
before, right?
Yes.
I don't have my stylus here, so I cannot write small. My fingernails are very hard. So you can do something like a okay, you can do something like a oh, sorry, maybe you have a for loop, and then inside that for loop you can create the variable and then set the value of the variable, initialize it, okay? You can do that, and then maybe I should be less than 5, okay, or any number you want. Then I plus, okay? So you can do something like this where you can initialize and set the variable inside the body. That's what the gentleman is asking.
Okay, sir. Thank you, sir.
Yeah, so you are right. You can do something like that. And Mr. Senna, any questions?
Yes, sir.
Hey, Madam Senna, sorry.
Yes. Please, with the flow charts, can I decide to use any of the objects there? I mean, the diamond, the rectangle, and the arrows. Can I choose to do it anyhow, or it must follow this pattern?
I don't know. I've not checked the book well, but there are 4 shapes in flowchart design. Okay, we have the start symbol, which is a oval, right? Start and end is an oval. Then we have a process, something called process. Okay, it's a rectangle. Then we have the input and output, it's a parallelogram. Then we have the decision, it's a kite. And then we have the lines with the arrows, okay? So with these 5 shapes, you can represent any sequential program. There are, you can check it on maybe Google or something, flowchart symbols. Okay, you have the explanation there, and then there are a lot of examples. Or even if you pick any programming, if you pick any maybe of the first handbooks in programming, you can learn a lot of things from those kind of material. Okay. It's unfortunate I've not seen it in this book explained extensively, but you can check out some of the reference materials. You see reference to how to design flowcharts. Okay. Good.
Yes, even those who are teaching at JHS, the JHS computing book is there, especially
Pardon?
Form 2. I said those who are teaching at JHS, you can ask your police teachers. It is in their JHS computing book.
Okay,
Especially
okay. So your friend is saying that those of you who teach at GHS, they are supposed to learn these things. It's in the book, the GHS book. What each of the sheets represents and how to draw, and those examples like that are in the GHS book. Okay. Mr. David, Courtney.
Hello, sir.
Yes, sir.
This one is a little bit I don't know how I should put it, but I'm intrigued about the very thing you said. Does it mean that code gives a specific let's say slide that you're supposed to go by, and without that, let's say you can't add more to it? Or I don't know, I'm a little bit confused. And if that is the case, are we going to be provided by their slides, or which one should we go by? Thank you.
My dear friend, these ones are not slides. So this is a book that we are all using. For the people on site and all of us online here are using the same book. Okay, so that's why I wanted us to all use one book. Okay, so that and some of you were complaining that I'm teaching something different, I'm doing this and that. So I want us to understand that we are all doing the same thing. I'm not teaching anything different. The slides I was using previously are just because I wanted to simplify the material in the book for you and maybe put my own personal examples in there. Okay, but I'm basically teaching the same material. I'm not teaching anything different. Okay, that's why the slides were just so that I can teach like how you teach in the classroom. Okay, but it's not anything. I'm teaching. There's the same material. Okay, and this is a book. This is not a slide. Okay, it's a book. Okay, it's a book. Please, we are all following the material so that we can all write the same exams. Okay.
Hello, sir.
Please,
Hello, sir.
we are spending all the time on this thing. Can we move on?
This one is just a follow-up, sir.
Can you just let me teach, and then later on after my class?
Okay, sir.
Yeah. You just follow up with me personally, okay? So that I can teach. I need to teach the class, okay? Okay. Thank you very much for letting us continue. Okay. Now we are going to look at the other type of loops or for loops. Sorry, other types of loops. I said that the for loop is only one example of a loop. The other example is called the while loop, and we use the while loop when we don't know the number of times we want to run something. Okay, so we call it a sentinel control loop. Okay, it is a sentinel because we don't know the number of times. So if you don't know the number of times, then you'll be checking not the number of times the thing is running, but you'll be checking a particular number or a particular condition. If we see that condition or we meet that number, we stop. But if we don't see or meet that condition or that number, we continue. Okay, so this while loop can run your condition. Hello? Can you hear me?
Yes, sir.
Okay. Then you put your condition, okay, your condition in the bracket over there. Now here, remember your condition is not counting anything, but it is checking whether a particular something has been triggered. Okay, a particular number or a particular word or a particular phrase or something has been entered or something has been reached. Once that particular number has been reached or that particular thing has been triggered, we stop repeating the body loop. Okay, so that is what that one does. Any questions? Okay, sure. Okay, so with the while loop, we write it so that we can check a condition for a particular value. Once the value has been seen or entered, we stop the loop. Okay, so it means that we keep repeating the loop while that condition is true. Okay, when the condition is not true, we stop. Okay, so let's see how that can be written. Okay, so I think there's an example down here. Okay, so I'll just explain with the flowchart first. So we are testing, remember the condition is a question. Okay, so we are testing whether the condition is true or false. If the condition is true, we go and run the body of the while loop, and then we come back and ask the question again. And we keep repeating this cycle. We keep repeating this loop over and over and over until the condition turns to what? False. When the condition turns to false, we go outside the while loop. So the loop only works when the condition is true. When the condition turns false, we go outside. What it means is that we must find a way to check or to change the answer inside the body of the loop. Okay? So inside the body, we must find a way to change the answer so that when we want to stop the loop, we can just change the answer to false and then stop the loop from running. Okay. So let's look at this example. Okay. So in this example, same thing we saw, but here we've changed the thing a little bit. We see a snippet. Here we create a variable called I. And then we set I equal to 1. Now we check, is I less than 5? That's the condition. If I is less than 5, then we come and print I. So we will print what? 1. The first time we run, we print 1. Then we do plus plus 1. What it means is that add 1 to I. So 1 plus 1 is what? 2. So 2, and then we ask, is 2 less than or equal to 5? Yes. So we come and print 2. Then we add 1. So we get 3. Then we test, is 3 less than or equal to 5? Yes. So we come and print 3. Then we add 1. Then we check, is 3 less than or equal to 5? Yes. So, sorry, is 4 less than or equal to 5? Then come and what? We come and print 4. Then we add 1, we get 5. Then we check, is 5 less than or equal to 5? Yes, 5 is not less than 5, but 5 is equal to 5. So you have to write the 5. Then we add plus 1. Then we come and check, is 6 less than or equal to 5? No. So once 6 is not less than or equal to 5, you stop. And so these are the numbers that will be printed. Okay, 1, 2, 3, 4, and 5. Okay, so this is an example. Now I want to write another example here for you to see. So for example, in this example, I'm going to write, okay. So in this example, I'm going to write, let's create a variable called answer, okay? And then we set it equal to something, okay? Then we check while answer is not equal to 0, let's write the value of answer. So we write maybe the value of answer. Now we must find a way to ask or to collect answer again. So we do input answer, okay? Then yeah, so this is a small program in pseudocode which is going to keep asking for answer and keep printing until we enter 0. Okay, it will keep running until the user enters 0. So how does it work? So for example, when we start the program, maybe we entered answer as maybe 5. Okay. Now, while 5 is not equal to 0, because 5 is not equal to 0, the answer from here is what? Is true. So we write 5, and then we ask for answer again. Maybe this time around, I say maybe answer is maybe 7. So because answer is 7, I come and ask the question, because remember it's a loop. So to come back to this place, so I come and ask, is 7 not equal to 0? Yes. So we will print 7. So first time we printed 5, second time we printed 7. Then we come and collect again. Maybe I enter answer as, maybe I entered answer as 12. Then we check, is 12 not equal to 0? Yes, 12 is not equal to 0. So the answer is still true. So you print 12. So we print 12. Then we come and collect answer again. So maybe this time around, I entered maybe 0. Then we'll go back and then we'll check whether 0 is not equal to 0. But this time around, 0 is equal to 0. So the answer over here is no longer not equal to, but the answer over here is what? False. So because the answer is false, we stop the execution. And so we only printed 5, 7, and 12 based on the loop we have over here. I hope we understand what I just explained. It's another example. I want you to see how the whole thing works. This type of loop, the while loop, what it does is that it can allow you to continue running so long as you did not enter a particular number or a particular character. Okay? But for the for loop, you need to know exactly the number of times you want to run something. Any questions? Let's look at the last type of loop, which is the do while loop. Okay.
Sir.
So yes, sir.
I want to ask whether in exams, if you are asked to write maybe a particular program using for loop or while loop, are you going to write it in a specific language or pseudocode?
Oh, I think that this program, they will ask you to, we are not expecting you to know a particular language. Okay, so you are allowed to write. Hello? Did you hear me?
No.
I said you are allowed to write in pseudocode.
Okay, sir.
Okay. But if you know any programming language too, you can write, I'm sure. Okay?
Okay, sir.
Chema, oh, you good. And the over trader were Python and Java.
Okay.
Abudu.
Hello?
Yes, so over trader were Java and Python.
Oh, but I just answered you.
Or that draw of French.
So hold on. Hello. Please, it's being recorded, okay? So please behave yourself. Behave yourself. Okay. And you can write in, if you know any programming language, you can write, okay? But we are not expecting you to write in a programming language because we've not taught you a programming language, okay? We are teaching you generic programming, okay, with pseudocode. The examples in the book are usually written in pseudocode or in Python, okay? But you can write in C++, you can write in C, you can write in Java if you want to, or you can simply write in pseudocode, okay? Mr. Richard. Am I the only one who can't hear you? Mr. Richard, I can't. Okay, let's continue. I cannot hear Mr. Richard, so we will continue, okay? Let's look at the do-while loop. So the do-while loop does exactly what the while loop does, but this time around, it does a little bit differently. Okay, the while loop is called a pre-test loop. What that means is that for the while loop, we test before we run the code. Notice that the test is up here, and then the code is in here. Okay. But for the do-while loop, that is not the case. The do-while loop is called a post-test loop. What it means is that the do-while loop will do the same thing, but this time around, we will run the code before we test. Okay, so see that the test is down here, and then the body of the loop is actually up here. Okay, the body is up here, and the test is down here. So it means that you will run the body before doing the test. Okay, you run the body and then you do the test. For the while loop, you do the test before running the body. So if you are writing a program and you want to run the body before testing whether you have to repeat, then you use the do while loop. But if you are running a program and you want to test before repeating, then you use the while loop. Okay, but they do the same thing. Okay, and the only difference is the position of the test. Okay, so let me show you. Loop is very simple as well. Same generics over here. So yeah, so you can see in the example over here, you can see the body is up here. So we run the body, then we come and do the check or the test. If the test is true, then we go and run the body again. We come and do the test. If it is still true, we go and run the body, we do the test. We keep going around in a circle until the test result is false. When the test result is false, we go outside. Okay, so that is how the do while loop works. It's the same strategy. Okay, the only difference is that the test is down there and then the body is up. Okay, let me clean that and then I'll show you the example of how it works. Okay, so let's look at the example. So in this example, you can see a simple program which is checking whether adding numbers is adding some numbers. Remember, I've already explained what this one means. Okay, remember, if we see something like that, it means what it means is that sum is equal to what? Sum plus num. Okay, so that's what it's equal to. Okay, so this one, the shorthand is to write sum plus equal num. Okay, so everybody remembers from last week. Okay, the shorthand of this is this. Okay, so that's what you are seeing over here. So what is happening? So what is happening is that we can see that we have been asked to enter a number. So when you start this program, you enter a number. Okay, the number you enter is put inside the variable number. Then we add whatever is inside number to sum. Let's just say sum initially is set to 0. Okay, so what it means is that we have 0 plus whatever the user enters. So maybe if the user enters 2, 0 plus 2, and then can you hear me, please? Hello?
Yes, sir. We can hear you, sir.
This is Vodafone network. Can you see the screen?
Yes, sir.
Okay. And you can hear me well?
Yes, sir.
Okay. Wow. Okay. I thought you could not hear me. Okay. Okay. So let me explain. So we check, is the number you entered, is the number equal to 0? Because the number is not equal to 0, we will repeat these statements again. So we'll ask for the number again, and then maybe you enter a new number. Remember, the old number, the sum now contains the answer 2. Okay, and then maybe you enter the number 5. So now it will be 2 plus 5, and then the answer 7 will be put inside sum. So remember, now sum contains 7. Then we check, is 7 not equal to 0? So because 7 is not equal to 0, the answer is true. So you come back and repeat. This time around, let's just say maybe, remember, sum contains 7. So let me clean this one, and then let me put 7 over here. So maybe this time around, you entered the number 10. And then we add 7 plus 10, we get what? 17. Then we go and check, is 17 not equal to 0? So we get that, 17 is not equal to 0. So we'll go and repeat again. Now, when we go back and repeat, maybe this time around, you decide to enter 0. Maybe you decide to enter 0. So let's just say that the user has decided to enter 0. 0 plus 17, you still get 17. But because you entered 0, this time around, when we do the check of whether 0 is not equal to 0, we get false, because 0 is equal to 0. So that answer over there is false. And because it is false, we no longer go back up. No, we will not go back up, but instead we will stop and then go down. Okay, so that is how that one will work. Okay, so that for the do while loop, notice that for the do while loop, even if the first time you run the thing, even if it's the first time you are running, and the number you enter or the number you entered is 0, okay, it will go and do the answer. Then it will now realize that, oh, the person entered 0. So let's stop the person from running any further. Okay, so for the do while loop, it will do the thing before checking. But for the while loop, it will check before doing. Okay, that's the only difference between the how the two of them work. Okay. Okay, let me clean that. Okay. Okay. Let's quickly move to the next section. Okay. Section help you understand how the break statements and how the continuous statements work. Okay. Now, you can put a break statement in a loop. Okay, so you can see over here that inside or in this while loop, there is a break statement inside. What will happen is that when we do the check for this while loop and the result is true, we will have to go inside and run the code inside. Okay, now in running the code inside contains an if statement. Now the if statement is checking whether something is true or false. So when the thing is true, then we go and run the break. Now the break will tell us to stop running everything and go outside. That is what the break will do inside the while loop. The break will tell us stop running everything, stop everything and go outside. So we don't repeat when we see the break. The break tells the computer or it tells the program that stop repeating or stop running everything you are doing and go outside of the while loop. Same idea applies to the do while loop. If for the do while loop also, remember we will go and run the loop inside. Here we are not doing any check. Okay, but the only check we are doing is that we are testing whether the if statement or the condition is true or false. If the condition is true, we will go outside the while loop. We will not even run the do while loop in the first place. But if the condition is false, we will come and test the while expression and go back and rerun, keep repeating until either the while loop is false or the if statement is true, and then the break is run. The break will tell the loop to stop entirely. Okay? The break tells the loop to stop entirely, stop running the loop and go outside the loop. When you are running a loop and you see or encounter a break, you stop running the loop entirely. Oh, okay, let me go back quickly. Okay, I think we are on session. Oh, session 3. Oh, sorry, the thing keeps running back to the start. Okay, we'll get there right now. Okay. Okay, then finally, explain the continuous statement. When, unlike the break statement, which stops the loop from running entirely, the continuous statement tells the loop to skip a particular execution. So what happens in the continuous statement is that when you encounter a continuous statement, or when we encounter the continuous statement, if we are running a particular iteration of the loop and we encounter the test and the test is true and we see the continue, what it tells the computer is that don't continue running the code down here. Don't come and run the code over here, but instead go and run the next update of the loop. I think there's an example down there, so I'll show you so that you can better understand what it means. What it means is that, for example, if I'm running and I has reached number 2 and I see the continue, what it says is that don't complete the number 2, but go and run number 3. Add 1 or add 2 to I. Go and run the next iteration of I. Don't complete what is in I at that particular number where you saw the continue. Okay, so continue lets us run the next iteration, whilst break tells us to stop running the entire thing altogether. Okay, so break stops the entire thing altogether, whilst continue tells us to continue on the next iteration of the loop. Okay, let me see, there's an example or two. Okay, there's an example over here. Let me explain that very well. So here we have an example with a for loop. Okay, you can see the continuous statement. Okay, so you can see the continue. So when we are running, let's run this loop and see what happens. So when we start this loop, remember, when we start this loop, remember that I start 0. I is starting from 0. Okay, so we start I from 0. Then we ask, okay, is 0 less than the length of is 0 less than the length of the list called num? So we have a list over here. The list contains how many things? The list contains 5 things. Those 5 things are over here. Okay, so if we ask num.length, we are just asking for the size of the list called numbers. Okay, so we are checking, is 0 less than 5? Then because 0 is less than 5, we come and check, okay, if 5 or the value of num at that particular position, maybe num is equal to 3, is num equal to 3, num at that particular position, num at that particular position is number 1. Okay, num at that particular position is number 1. Okay, so we check, okay, is number 1 at that particular position, is it equal to 3? Because num1 at that particular position is not equal to 3, we come and print the value of num at that particular position. So we print the value 1. Okay, so let me write num at that particular position, okay, is 1. Okay, then we run, because it's a loop. When you get to the end, you come back again to the 4. Okay, when you are coming back, you have to increase I plus 1. So now I is no longer 0. Remember, I is what? I is 0 plus 1, so you get 1. Okay, so you check, is 1 less than 5? Because 1 is still less than 5, you go and pick the next number. Okay, so 2. So you check, is 2 equal to, or is 2 equal 3? Because 2 is not equal 3, you skip this one, okay, because it's false. Okay, so you come and do print num, so you print the value of 2. Okay, then you go back up again, then you come and add plus 1, so now you get what? 2. The third position is 2. Okay, so remember, we are here now. Okay, the last one we ran was this one. Okay, so we are here now. So we check. Let me clean the number, and now we check, is 3 equal to 3? Is 3 equal to 3? Because 3 is equal to 3. Remember, this is true. This is true. 3 is equal to 3. It's true. So because it is true, we come and run the code inside. When we run the code inside, what it says is that don't continue down there, but instead go and repeat or go and do the next iteration. So we will skip the blue one and go and do the next iteration, which is I plus 1. So I plus 1, now we have to compare against what? 4. Okay, is it 0, 1, 2, 3? Oh, sorry, it's 3. So sorry, so here it's supposed to be 3. Okay, the first one is 0, second one is 1, next one is 2, so the next one is 3. Okay, so 3, so we come and check. The third one is the number 4. Okay, so the number 4, so let's clean this one, and then we come and do the number 4. Okay, so 4 is not equal to 3, so we come and print 4. So you see 4, and then we continue and then go back up again. Then let me check if I have a number. Okay, then we come and print the next one, so we come and do 5. Okay, then we stop. So notice that we skipped the number 3 because when we got to 3, we were asked to continue. Continue means don't go to the one down there, don't finish the code, go back to the next iteration. Okay, is it understood? Continue lets you go to the next iteration, but break will stop the code from running entirely. Is it clear? Okay, I hope you understood me. Then the next key issue we need to look at is how to put loops and if statements or selection statements inside each other. We call it nesting control structures. Okay, nesting means to put something, just like how the bird builds the nest. It will pick one small item or one small string, and come and put another one inside, another one inside, another one inside. So programmers call the idea or the way we put one item inside another, we call it nesting. Okay. And you can nest a lot of things. Okay. You can nest if statements, you can nest loops and so many other things. Okay. You can put even ifs, you can put if statements or loops inside each other. Okay. Now let's look at an example. Okay. Let's look at an example. So section 4, we start with an example of a nested if statement. So we see that if you want to nest, this is an example of nesting. Okay. If we want to nest, notice that this is an if else statement. Okay. Originally, this is the true part of the if statement. Okay. This is the true part. And then this part is the false part of the if statement. Okay. Then when you look inside that if statement, there is also another if statement inside. Okay. Sorry. There is also another if else statement inside. Okay. So do you see that? That if else statement has a true part and then has a false part. Okay. So you can put if or if else statements inside each other, just like how it is done over here in the example you are seeing. So I'll scroll to the example down there so that we can immediately explain what is happening in the example over there. Okay. So when we look at this example, okay. So when you look at this example, we have a variable called, let me minimize a bit, okay? We have a variable called x. X contains the number 10. And then we are checking, oh, but before then, look at this if statement. Well, this if statement is an if-else statement. You see? It's an if-else statement. It has a true part, okay? A true part like this. And then it has the false part, which is down there. Notice the position of the else. Please notice the position of that else. And that else is aligning with this if. Okay. The else is aligning with this if. Okay. Then notice that there's a second if else statement over here. This second if else statement has also its own true and has also its own false. Okay. And like I was saying earlier, it has, wherever there's an if else, you see the if and then you see the else. Okay. So let's do the check. So because we know that x contains 10, let's check. Is 10 greater than, right? Let's check. Is 10 greater than 0? Is 10 greater than 0? If 10 is greater than 0, then we go and write positive number. Okay? Because that is inside the true part of the if statement. Then we are not done, because inside that same part, we are checking the number that we are holding, the number. If you find the modulus of the number, the modulus of 10, okay, if you find the modulus of 10, so 10 modulo 2, will it give you 0? If you find 10 modulus 2, will it give you 0?
Yes, sir.
So because 10 is even, because 10 is an even number, when you find the modulus of 2, right, you get 0. Okay. So because you get 0, it means it is true, and so you do the true part. Okay. But if it was false, then you go and do the false part. Okay. So notice that we only do the parts which are true or false based on the responses. What if X was not 10, but maybe X was let's say X was maybe 13? Then the first part will be true, so we say positive number. Okay, we know 13 is a positive number. Okay, then but the second part, 13 modulo 2, 13 modulo 2 will not give you 0, but will give you 1. Because it will give you 1, we don't do even number, but we come and do what? Odd number. Okay? Hope you all understand. Okay, that's good. Good feedback. Okay. What if the number we were holding was maybe 5? Okay, so 5 will also result in what? 5 will result in positive number, but 5 will also result in odd number. Odd number, because 5 is an odd number, right? When you find the modulo of 2, the modulo of 2 on 5, you get what? 1. What if the number was what? Minus 2? Minus 2 will mean that X is not greater than 0, because minus 2 is not greater than 0. And so we go and do the false part, which is what? Negative number. Okay, you guys can see down here, negative number. Is it understood well? Okay, that's good. Okay, then with the loops as well, you can do nesting of loops. So how do we nest the loops? We have said that nesting means you put one inside another. Okay, so an example is what you can see. You can see the first loop, which is the loop with the block 1. Then you can see the second loop, which is loop with condition 2 and block 2. Do you all see that? In fact, you can put in a third loop, a fourth loop, a fifth loop. You can put in as many of them as you, the programmer, you can understand. Okay, but we don't advise you to nest it too deep. It becomes very complicated, and sometimes it can spiral out of control. Okay. So let's see an example in practice. Okay, so look at this example. In this example, we have the first for loop. I 3 times, because it's starting from 1 and ending at 3. Please always check that part. Once you are talking about for loop, it means you are doing a definite number of iterations. So always check where it starts and where it ends. Okay? Very important and very simple to identify. Then there is a second for loop, which is inside the first for loop. This one is also counting, but it is counting from 1, while J is counting from 1, and J is ending at 2. So let's do a table of I and a table for J. Okay, so the first time we run, I is 1. Then we check, is 1 less than 3? Or 1 less than or equal to 3? Yes. So we go inside. Then we see the for loop with the J. J is also what? 1. So we check, is J or is 1 less than or equal to 2? We know that 1 is less than or equal to 2. So we allow it to run. So when we run, we will see the value of I, which is 1, and the value of J, which is what? Also 1. Because we are inside, we have to finish the one inside, because the one inside is the one which is currently looping. Okay, remember I is still 1, but j is the one now looping. Okay, so we'll add, remember j is j plus plus, so it means we have to add 1. So we add 1 to 1, we get what? 2. So it means j is now what? 2. So we see 1 and 2 because 2 is less than or equal to 2. Okay, then we add plus 1 to j. Now j is 3, but 3 is not less than or equal to 2. And so once we get to 3, we stop the one inside and go back outside. When we are going back, we have to add the plus 1. So we now have what? 2. Then we come back inside because 2 is less than 3. So we come in now. When we are coming back inside, remember we are now starting the inside one again. So j is 1. And then we repeat. So we have 2. And then we have 2. Then j will increase plus 1. Then we come back inside. Okay, sorry, we go to the one outside, we add plus 1. So now I is 3. Then we come back inside. When we are coming back inside, j starts again from 1. And then we do the repetition again. So we have 3. And then we have 2. Now remember, whenever the j gets to 2, we have to go back outside. When we are going back outside, I plus 1 is now 4. 4 is not less than or equal to 3. So we stop. So we will stop. Can you hear me, please?
Mike, yes, sir.
Okay, sorry about that. Okay, but do you understand what I'm explaining?
Yeah, we better take it again.
Sir, take it again.
You want to set it.
Yeah, even the mic was not coming, or is it the network?
The network? Is that a network?
Yes, at some point in time, you went, the audio went off.
You can hear me from here?
Yes, sir.
Okay.
Yes, sir.
Okay. So what is happening is that we have how do I call it? We started from when I and j were 1, right? Remember, I'm explaining nested loops to you. Okay. So in nested loops, in this example, for instance, you are seeing that I'm nesting I, or I'm nesting j inside I. There's one loop which has a counter variable called I, and a second loop which has a counter variable called j. So let me try and mark that I, and then a second loop which has a counter variable called j. Okay. Now what is happening is that I'm helping us to keep track of I and j. Okay. Now when we oh sh I don't know why it keeps coming back to the top. Okay. I think we've explained this earlier. Okay. Okay, this is where we were. Okay. So when we check, I starts at 1, then we check is 1 less than or equal to 3. Because 1 is less than or equal to 3, we go outside, we meet a second loop. Remember, the one outside is the outer loop, and then the one inside is the inner loop. We run the one outside, and then we have to go inside and run the one inside completely before coming back out to update the one outside, come back inside, and then run the one inside from the start to the end, go out again, come back inside, run from start to the end, go out, come back inside, keep repeating that until the one outside is false. Okay, so that's the idea. So the first time we run, I is 1, and then we check is 1 less than or equal to 3. Because 1 is less than or equal to 3, we go inside, and then we see that j is also 1, so we record j as 1. Then we check is 1 less than or equal to 2. Yes, 1 is less than, because 1 is inside j. Okay, so we run the code inside. The code inside says print the statement I and j. So we'll print 1 1. I is equal to 1, j is equal to 1. Okay, then we will have to come back to the red for loop where the j is. Remember, every time we do the run, we have to update. Okay, so we do +1. When we are doing plus, remember, we are only doing +1 for the j, not +1 for the I. Okay, we are only doing +1 for the j, not +1 for the I. So I is still 1, but j will now be what? 2. And so we check, is 2 less than or equal to 3? Yes, 2 is less than or equal to 3. So we have to do what? We have to now come and run. We have to come and print the statement again, and then we'll get 1 and 2. Now we come back. When we are coming back to the red, we still do +1 because it's j plus plus. So we do +1. When we do +1, we get 3. But 3 is not less than 2. Remember, j over the j test or the condition says that j must be less than or equal to 2 for that one to be true. So because 3 is not less than or equal to 2, we don't run that one. It is false. So we go back to the blue one. When we are going to the blue one, remember, we have to do the update now for the blue one. So when we are doing the update now for the blue one, it will be 1 plus 1. So remember, ji was 1. So +1 is now 2. We check, is 2 less than or equal to 3? Yes. So now I is what? 2. So we have to come back inside. When we are coming back inside, j is now reset to 1 because that is what it says. Int j equal 1. Every time we are coming back, it starts from the beginning. So now j is equal to 1, but I is equal to 2. So we do that one. Then we do +1. So we get 2 and 2. Then we know that because j stops at 2, we have to go back out. So we do +1. Now I becomes what? 3. And then j now starts from 1. So we do +1
plus 1 again, we get what? 3 and 2. It will stop at this number because when we come back out again, J is now, or J is no longer, sorry, J is
4.
It's 2. Sorry, J is 2, but
2.
I, when you add 1 to
4.
I becomes 4.
4.
And remember, we said that I must be less than or equal to 3. Okay, so please take note. I must be less than or equal to 3. So that is where we stop. When I is no longer less than or equal to 3, we have to stop the one outside. When we stop the one outside, everything stops. Because when the outside one stops, we stop the entire loop altogether. I hope it's understandable. This is the second time I'm explaining the same thing. So I hope you are following, please. Hello. I hope it's understandable now.
Yes, sir. Yes, sir. Yes, sir. Come over.
Okay. Okay, that's good.
Yes, sir.
Okay, I'm glad you understand it now. Okay, so let me proceed. Proceed. Okay. Okay. So this thing, I don't know what is wrong with it. It's coming back to the top. Okay. Okay, so that's what we just looked at. Okay, so there's another example. Okay, so there's another example over here, which very easy to understand. Here is an if statement. We are checking whether you have, we are checking age and checking whether you have a license or not. Okay, so here, if the age is greater than 25, greater than 18, then we also checking, do you have a license or not, right? Is the license true or false? So if the license is true, we come and print, you are eligible to drive. Because in Ghana, you must be above 18 years and you must also have a driver's license. Hope you can concur. Okay, so what if you are above 18 years but you don't have a driver's license? Okay, what that will mean is that even though you are above 18 years, you need a driver's license in order to drive. Okay, so you'll be above 18 years, but you would need a driver's license in order to drive. Okay, but what if you are below 18 years? I don't think there's anybody below 18 years who has a driver's license. Okay, so if you are below 18 years, then it means all of this is false, and the only one that will run is the one down here. Okay, you must be at least 18 years old to drive. I hope you understand what the explanation to this one also was. Okay, so in summary, what it actually saying that you can put loops inside each other. You can also put if statements inside each other. Okay, and there are some examples for you to practice on in the end. Then the last but not the least is that we discuss about error handling, how to handle errors in the programming. So in programming, when you make a mistake, okay, in the programming, you can correct, or you can write certain code which may handle the error. Okay, we call them exception handling. Okay, for example, you anticipate that in your programming, a user may enter a wrong value or a user may make a mistake. Okay, so we call that exception handling. And then in the programming, you can make errors. So we call those ones, they depend on the type of error, we have a name for it. We have errors can be classified as what? Syntax errors, or we have errors which are called logical errors,
or we have errors which are called runtime errors. Now, what is a syntax error? A syntax error is an error which violates the programming language's syntax or the rules. The rules for a programming language are called the syntax of that programming language. Okay, the rules for any programming language are called the syntax for that particular programming language. And when you flout the rules, for example, if you are writing in Java and they say end every statement in semicolon, but you decide not to end the statements in semicolon, we say that you have violated a syntax or a rule of the programming language. Okay, so that error, you can easily correct it by entering the correct or using the correct syntax. Okay, so that one is very easy to prevent or to correct. Another example is that when maybe you open a bracket but you don't close it, we call that parenthesis, mismatched parenthesis. Or when you open a square bracket, you don't close it. Or when you don't even open at all, but we are expecting you to open it. Okay? Or when you do wrong spelling, okay, misspell words. Or when you don't bring the semicolon at the end of your statements. Or when you use, maybe you're supposed to use less than or equal to, but you turn around and now do equal to before the greater than or equal to before the less than. That one too is an example of, that one is also an example of mismatched, or sorry, an example of an incorrect operator use. Okay, the correct way you should be doing it is that you should always have the less than before the equal to, and then the greater than before the equal to. Okay, so if you do the other way around, it is not, you can easily correct it because you see that you have written the wrong thing and then you correct it by rewriting the correct thing. All of those ones are called syntax errors. They are easy to see and easy to correct. Okay. Then logical errors are a little bit difficult. So logical errors have to do with mistakes in the way the program has been written. Okay. So for example, if you are expecting to do maybe x plus y, but when you were writing, you were in a hurry and then you entered x times y. Notice that you always get an answer, but the answer is not going to be addition of x and y. Okay, so that one is incorrect. It will give you an answer, but the answer is incorrect. Okay, so that one is called a logical error. Okay, so logical errors are also a problem, and you can fix them. They are difficult to spot. Okay, you can fix them, but they are also difficult to spot. So examples include what? Maybe using the wrong conditional statements. Maybe you didn't write the loop well, so the loop will keep running. It doesn't want to stop. Okay, or you use the wrong mathematical formula or calculations. Most times that's what people do. People divide by 0 and they do other very scary mathematical operations. So those ones too are all classified as what? Incorrect mathematical formula or calculations. And then incorrect order of operations. Maybe you're supposed to do the data entry first. Last time I was telling you about the framework for input processing and output, IPO. Maybe someone forgot or they were not listening to me. And when they were writing their programs, instead of doing input first, then doing the processing before doing the output, they rather chose to do the processing without collecting any input. Then later on down there in their program, they will now do the input before they do the output. So in programming, you can't do the processing if you have not collected any input. Okay, the computer, when you write the program and you try to run it, it will tell you it cannot generate the answer when you have not given it anything. Okay, so that one is an example of logical errors. Then we have some errors which occur when you run. Okay, you only spot them or you only see that this is an error when you click on the run button. Okay, we call those ones runtime errors. So an example is when you design a program, it's correctly written, the mathematical formula is correct, but maybe one way or the other, a particular input the user entered. Once we click on run and the user enters that particular input, it results in an error. Okay, we call that one runtime error. An example is division by 0, or you are trying to access a memory location without any data, or you create an array, maybe you create an array of 3 things, but you want to call 5 things or 10 things. Okay, we call that one array out of bounds index. Okay, and then when you don't have enough memory in a particular, or you use the wrong data structure or the wrong data type, right, it results in something called stack overflow. Okay, so all of these are types of errors which you as a programmer need to understand and know what they are. Okay, now when we are also writing, we can write our programs in such a way to prevent them from generating errors. Okay, to prevent them from generating errors.
The screen is off.
Oh yeah, I'm trying to get it back on.
Yeah, the screen is off.
Sorry. Can you see me now? Sorry, can you see the screen now?
No, say.
Not yet, please.
That's okay. Sorry. You can see it now?
Yes.
Okay, sorry about that. Okay, I think I touched the button. Okay, so how do we write our program so that if we are anticipating that we don't want the user to use or to enter particular values, we can prevent the user from doing those things? We use what we call exception handling. Okay, so in programming, we can handle exceptions using something called a try-catch block. Okay, so how does this work? We will write the entire program inside a structure called the try-catch. Okay, and basically what it does is that the try-catch will try a particular operation, and if the operation does not result in an error, it will allow the operation to happen. Okay, but if the operation results in an error, it will try and catch that particular error and prevent your code from crashing or your program from doing that error. Okay, so for example, you see this code, we are anticipating that when we run any of these two statements, right, we are going to get some errors. Okay, in fact, the problematic statement is this one over here. Okay, we are trying to divide 10 by 0. Okay, you know that we can't in mathematics, when you were learning your mathematics in secondary school and GSS, we learned that we can't divide by 0. Okay, so when you try to do division by 0, we are going to get what we call runtime error. To prevent the runtime error, hello, who's on the call? You want to ask a question? Okay, so to prevent the runtime error, we have put the entire thing inside a try-catch block. Okay, so we are trying it. If there is no error, we allow the code to run successfully. But if there is an error, we use this statement, the catch statement down there, to catch what we call the standard error. And then we write some explanation for the user. So what will happen is that the program will continue to run, but you will see that small error appear on the screen. and then the next, and then you can run the next statements that appear after it. Okay, but if you don't put the entire thing inside a try catch, the program will stop abruptly. Okay, it will not run the way we want it to run. It will just stop without telling us anything. Okay, so the try catch block tries to catch some of the errors and then report back about what the errors are. Okay, now you just need to understand what it does. That's all. Okay, you're supposed to just understand what it's supposed to do. Then last but not the least, for the unit 3 is to our talk on debugging. So what debugging is that debugging is when we are fixing the errors in your code. Okay, when you fix the errors, it's called the errors are called bugs. So when you are fixing them, we call it debugging. Now, what debugging is that we need to just come up with a technique for identifying the errors and then removing the errors or looking at statements which may result in our code not functioning properly. Okay, so that is what debugging basically entails. Okay, so how do we, common ways we can use to do debugging, we can use what we call print statements. Okay, you can sometimes print some things or some output from your code so that once you see those outputs, you know whether your program is running successfully or correctly, or your program is running incorrectly, and then you need to do the fixing of the errors. Sometimes we can use small print statements inside. We call them login. Okay, console login. So console login will log some information to the console. That's the terminal, which will tell you whether your program is running successfully or unsuccessfully. Then you can also use a standard tool called a debugger. Okay, so when you are using a tool like an IDE, IDE stands for Integrated Development Environment. Okay, we download them. An example is Eclipse or Android Studio, right? Or Java, how do you call it? NetBeans IDE, right? Those ones are called IDE, right? They are packages which contain debugging tools, so that when you are writing the code, they'll be underlining, maybe they'll be underlining the wrong code or suggesting some of the correct things you can do, or even suggesting some additions to your code or some refactoring you can do to your code. Then we have something called the rubber and duck debugging. What it simply means is that usually programmers will have something like a toy rubber duck in their hands, and as they are fixing the errors, they'll be squeezing the rubber duck, and then they'll be mentioning or reading out their code, right, which will help them get ideas as to how to fix the errors. Then divide and conquer simply means you divide the program into small chunks, and then you try and look at the small parts of the program step by step. Okay, then code review is when you look for someone who also understands the programming, colleagues of yours, who will now look at your code and try to help you debug. The unit testing is when you are building your code in small chunks. You do testing on the small chunks of the code. And version control is when you keep track of the code you are writing using something called versioning software or version control software like GitHub or Git. Okay, and then we have something called error message or review error messages, right, or stack traces. Here it's just like login, but we use try catch blocks to try and tell us where the error is coming from. Okay, so the debugging is very instrumental when we want to write very big programs. Any questions about the three, what we have done so far? Any questions about what we've done so far? Yes, any questions? I'm opening the next section. so we can have a look at what we need to do.
Hello, sir.
Yes, sir.
I want to ask where this error falls under.
Pardon?
Example is when you are commenting on your programming using
Yes.
the backslash, and you later on go and use front slash.
You later on go and do what?
Use front slash.
// Okay.
Yes, sorry. So
Okay.
where does this error falls under?
Oh, that's a syntax error because it's a mistake. It's syntax error. It's a mistake in the syntax.
Okay, sir.
Okay.
Thank you.
You're welcome. Yes, any other? I want to open unit 3 and unit 4. Okay. Yes, any other question?
Yes, sir. You mentioned something like console.
Yes, console. Yeah. What about it?
I don't understand. I'm having two mindset about it. I don't know whether you are referring it's about the output of the program, or it refers to the programming editors.
Console? No, console. What about console? Which part of the console thing did you not understand? So I can be specific, and then we can all understand your question.
Specifically, the meaning of console in programming.
Oh, where did you hear it so that I can explain? I cannot explain. It will be a bit technical to try and tackle that whole thing. So that's why I'm asking. Yeah. Hello? Are you still there?
Sir, when we were talking about the identifying and fixing errors, you talked about logging to console. So
yes,
like
okay,
simply,
okay. So in that particular place, okay. So when we say we log to console, some of the programs are graphical. You know, your programs are mostly written as graphical. Oh, sorry. I don't know why it keeps locking. Okay. So your programs are mostly written as graphical user applications, right? Are you with me?
Yes, sir.
Okay. So because they are written as graphical user applications, what is happening is that sometimes if there's an error, it becomes difficult to find out where the error is. Now, the console is just like that black screen. I don't know if most of you have seen command prompts before. Have you seen command prompt, or do you know what command prompt is?
Yes, sir. Yes, sir.
Okay, so the command prompt is that black screen you normally see. For those of you who have seen it before, you see that it's only text. There's no graphics inside that screen.
Yeah.
And that is what we refer to. It's an example of what we refer to as console or terminal. Okay, what it means is that we will, instead of having graphics or having the output of the program as a graphics application, we will try and log the information in that black place. It's called the console. When we log that information in that black screen or on that system, it's called the console. It makes it easier to know what the error is. But of course, the error you see on the console is textual. Okay, it's text. It is not graphics. It doesn't come like a nice screen looking very nice for you and those things. No, it comes as text. Okay. Okay. Are you okay? The guy who asked about the console thing.
Yeah, I'm okay, but there's still an iota of confusion.
Oh, really? What is it?
Yeah.
What is it? I'm here. What is it? Please ask quickly. Ask quickly. We don't have time.
So what you are talking about, the prompts from the CMD. So
you know what it is?
Yes, please. I know that I've been using CMD for other things.
Okay.
So the console, is it about the platform or is it about output?
Oh, but you said you know what it is. Hello.
Yes, sir.
But you just said you know what it is.
No, you are using a CMD as an example. If you want to
Yes.
create something.
Yes. So
Yes,
I'm saying that we can, when we are programming, for example, if you are writing a program in Java, instead of having the program or the output of the program appear as graphics, if we are having a particular error, which we don't know where the error is, we can have the program talk back to us in the console. There's a way to do it. You have the program print output or print some statements inside the black screen.
Okay.
That's what we mean by console.
Okay.
Or sometimes in the IDEs, like maybe IntelliJ or maybe Eclipse or those other programs, you see that a PyCharm, yes, there's a small black terminal down there, and you see the output inside. So that's the console.
Okay.
Yes. So I don't.
Yeah, it will tell you about the line where the problem is.
Yes, it will tell you. Yes,
particular
sometimes
line.
it can tell you. Yes, it can tell you the line. It can tell you the piece. It can tell you the column number and all those things, or the class, or the particular file that the problem is coming from. It can tell you even how to fix the problem.
Okay, sir. Thank you very much.
So that when you do the programming and you use that one, you find it very easy to do that one. Okay. Okay. So the next important topic we have to look at. I don't know how many minutes do we have. We have about. The class ends at what, 7:30 or 8:30?
8:30.
Okay, so we have more time. Okay. So today we'll add up functions, because next week, according to our calendar, next week is the last class for the face-to-face. Okay. So I'll add up a little bit and we'll finish at 8:30. Okay. So yes, sir. Please allow me to do the teaching. Allow me, I beg you. In the name of God. Okay. It is for your own benefit. Hello.
Okay, sir.
Okay, let me do the teaching, okay, so that you can. I'm just explaining what is in the manual for you, okay, so that you can understand it, okay.
Sir, even on the timetable, it's rather 8:30 that we are supposed to close.
Yes. So today we'll close at 8:30 and a little bit more, okay.
No, we don't have this manual.
Oh, don't worry, I can share. We have shared with them, so I'm sure there's a place they will make it available, but I can also share with you, okay. It's not anything. I can share with the course rep, and he can share with you, okay.
Thank you, sir.
Yes. So course rep, please contact me and remind me to send this to you, okay.
Okay, sir.
Yes, but
Okay,
I have shared with them, and then they will also share with you, okay, because the whole thing has 6 units, okay, 6 units. We've done only 3. Your book has only 3, but you need all 6, okay. So let me continue. Okay, so functions are a key part of programming. Okay, what function is that function is a way to group parts of your program which do specific things. Okay, so when we write small programs, we don't need to write them as functions. Okay, because as for a small program, they will only do something particular or something specific. But if we write very big programs, usually there'll be parts of the program which will be doing different things. And so we group those parts of the program which are doing different things into functions. Functions is a modular way to write programming, or writing programming in parts. Okay? So that each part does something specific. So unit 1 discusses what a function is. So for example, if you want to write a function to maybe calculate the area of a circle. So over here, you only look at the specific thing about calculating area of a circle. Okay, you're not focused on any other thing, like maybe what the circle width is, what the circle length is, and those. No. Your focus is that this function should take the radius, multiply the radius, the square of the radius by the pi value, and then return the area of a circle. Okay, that is what functions do. Usually, we don't have a function should not do more than one thing. It should do only one thing and stop, or one thing and return, and another function. If you want to do multiple things, then it means you need multiple functions. That is the purpose of functions. So now there are two main types or kinds of functions. We have what we call the standard functions or standard library functions, and then we have what we call the user-defined functions. When we say standard library functions, every programming language comes with its own functions built in. So for example, I see that most of you already know some programming. So for example, if you take Python, notice that you did not build the print. The print was built when you downloaded Python. When you downloaded Python, it came with print statements. So all you need to do is to just put the statement you want to print inside the bracket. And then when you run it, Python will print it. Because print is written by the programmers themselves, those who design Python. So it comes with the programming language. Those types of statements are what we call standard library functions. Okay, they are built into the programming language. They are usually doing things like calculations, dates, time, and different things like printing and utilities, input, and those kinds of things. Okay, so our example is length, input, random, date, time, and those kinds of things. Then because the programmers don't know what you want, they allow you, the programmer who is now having the Python on your machine, to be able to write your own programs, any program that you want, and write your own functions. So how would they allow you to do this thing? They allow you to build your own user-defined functions. When we say user-defined function, it means you, the programmer, you can write your own functions to do specific things. We call them user-defined functions. So an example is written, the syntax is written down here, and the example is what you see over here. So to write a user-defined function, you first need to write your return type, your data type. Okay, functions have data type. They are just like variables. Okay, but they are a bit different, and so we will learn why or how different they are. So you need to write the return type of the function. The return type of the function can be an int. Okay, the return type of the function can be a float. Okay, why is that T not coming? Okay, the return type of the function can be a string. Okay, remember we already discussed data types. Okay, the return type of the function can be I think character. Okay, and then there's a special type which functions value can take. Okay, there's a special type. So that special type is called void. Okay, so the return type can also be called void. Now, we use void when we don't want it to return any of the other data types. Okay, so if we don't want the function to be an integer or a string or a float or a character or a Boolean function, then we use void. Okay, so please take note of that. Now let's look at the example. Then remember the function name. Function name is very important, so you have to always have a name for the function. Then functions, because they do specific things, sometimes they take some data. So we put the data inside what we call parameters or parameter list. Right? It's called formal parameter list. Okay. Then inside we put the body of the function, the code that we want to do the specific thing. We put it inside the body of the function. Okay. Please take note of that. Okay. Okay. Now let's look at the example over here. So in this example, we have a simple function. This function is not doing anything intelligent. All it is doing is that this function is saying hello world. So look at the function declaration. We call this statement, the entire thing, the function declaration. Okay, so it involves the head of the function that tells us the data type of the function, and also tells us the name of the function. Then if there is any parameters, we put it inside the brackets. Then we open the curly brackets. The opening and the closing curly brackets are there. Okay, so the opening and the closing curly brackets. Then inside, we put the code that we want to run, which is the specific thing we want the function to do. So what is the specific thing we want this function to do? To say hello world. Okay, I hope everybody is having a look at this. Very, very convenient and easy to understand. Okay, functions must do something specific. Now, when you create a function, it's just like having a child. Okay, the child can be in their room, but if you need the child to do something for you, you have to do what we call a function call. You have to call the function. So how do you call the function? You, in your program, you have to do a function call by calling the name of the function followed by the parenthesis. Okay, when you do something like this, what it does is that the function will now go and call the declaration. Okay, functions alone are not useful if you do not call them. You need to call the functions. Okay, so that is what you are seeing down here. I'm explaining very briefly with this diagram. So you can see that in the main function or in the main method, we have a function call, and whenever we call this function, the function will go and call the code inside greet, and that code will run. Then when the code finishes running, we come back and complete or continue the rest of the program. Okay, any questions about that? Hello, can you still hear me?
Hi, sir, we can hear you.
Is it legible? Is it intelligent? Do you understand it? The concept?
Same.
Yes.
Yes, madam.
Please, I want to ask that.
Yes.
With the exam, is the exams going to cover
come on. I'm talking about functions. Please.
See, my hand has been up for a long time.
Yeah, but I'm not talking about exam. I'm talking about functions. I'm teaching something. Let me just do my teaching, okay?
Okay.
Thank you very much for understanding. Okay. Please ask me questions on functions. Okay, ask me questions on functions. Don't ask me about different things. Okay, I'm begging you. Okay. So do we understand the mechanism?
Hello, sir.
For yes, sir.
Sir, please. The function inside the void with the int main function. That's one. The one inside which is calling the void.
Yeah.
Does it mean that the one inside before it executes, it must pass through the first one?
Oh, it is not inside though. Look at it very well. It's not inside. It's not inside. Look at it very well. Where the brackets start and end.
Yes.
If you can see it clearly, it is not inside.
Yes, I can see it clearly.
Okay, so it means there are two functions, one on the top and one after it. The one on the top is called greet, and the one after it is called main.
Okay.
So what is happening is that this program, they took this example from C++. Okay. So in C++, there's usually a main function. Okay.
Okay.
This one is sorry. In C++, this one is by force. Okay.
Okay, sir. Okay.
This one is by force in C++. Oh, why is the marker not working? Yes. Okay. Okay. So in C++, this one you must have it. Okay.
Okay.
Now it is this one that we put all our code inside. But if we put all our code inside the main, it will be so long, and we cannot correct our errors. We cannot debug very well, because if we put all the maybe a part of the code is doing area, Another part is doing hello world. Another part is doing the length of a circle. Sorry, the diameter of a circle. Another part is doing the circumference. You see, that will be a very long and a very dirty program. Okay. So we group those different things into different functions, so that if we want to run only the greet, we will call the greet. Okay, we will have that code inside the main. Then once the program is running and it sees the greet, it will go and run only the greet, only that greet program, and then come back and continue with the rest of the program inside the main. That's the idea. The idea is that the thing you want to write in the main, don't write everything like that, but group them inside functions, so that you can call the functions when you want to use them.
Okay.
That's the idea.
Okay, thank you.
You're welcome. Okay, I hope it helps most of you. Okay. Now, let's look at why. Why? Somebody will ask, oh, but we can just put everything inside. No. Like I was saying, if you put everything inside, it will be difficult to debug. Okay, debugging is very important in programming. Okay, because in programming, some programs can be thousands of lines long. Okay, so you don't want to write a very long program. Instead, you want to write the program so that it is reusable, so that sections of it are reusable and the program is manageable. It's in chunks. It's doing specific things. We call it in programming, we call it modularity. Okay, so that's one of the reasons for function. Another reason for function is that you want to be able to read your program. If you have program which is grouped into small functions, you know exactly what each of those functions are or is supposed to do. So that's readability. And then you can quickly correct any part if there's an error. Okay, so it's maintainability. Okay, then functions allow you to do complex things like data abstraction. Abstraction means you don't want the user to be too concerned about the details. So you write all of those things and then you just represent the information or represent the program as something simple to the user, but behind the background, you are doing the actual work. So we call that abstraction and encapsulation. Okay. Then functions allow you to be more efficient. Okay. Functions also help you to collaborate and organize your code, because once you know what you should build, you let your team members go and build them. Once you come, you just put them all together and then build one program that contains all of those functions. So it is very easy to use functions. Okay. Now the next section looks at how to create the functions, because before you can use the function, you need to create it. Remember, I said that the entire thing about creating the function is called function declaration. Okay, so we're going to look at how to declare a function. Now, a function has two important parts: the function header and then the function body. The two of them together is called the function definition. Okay, creating the function is called function declaration, and we declare the function by writing the definition. Okay, so the function declaration is the part of the function which creates the function. Okay, the part of the function process which creates the function, or creates what we call the signature of the function. Okay, so before you can create a function, you have to know the data type. Okay, the name, and then if the function takes any inputs, the parameters of the function. Okay, so in this example down here, you see the data type of that function is called what? Int. Int is the data type of the function. Okay, then the word add is the name of the function. Then inside, just after add, you see the brackets. Okay, so the brackets, inside the brackets are the parameter or what we call the formal parameters of the function. Here, there are two parameters, A and B. The int in front of A tells you the type of data A is. So A is an integer. And then the int in front of B tells you the type of data B is. So B is also an integer. I hope we all understand this. Okay, so this one describes the function declaration, helps you to define the signature or the header of the function, or tells us the data type, the name, and the parameters. Okay, then the function definition is the actual implementation. When you actually write the function, that is what we call the definition. Okay, so how do we show the definition? You have to write the body, you have to add the body of the function. How do you add the body of the function? You put the curly brackets over there, and then you write the body, what you want the function to do specifically. Okay, so over here, you see in my example I have over here, you see that the entire thing is the function definition. So the entire thing includes the signature of the function or the header of the function, and then the code that makes the function, the body of the function. So are you understanding the differences between the two? So the function declaration states the function header. Okay, the function head, that is the data type, the name, and then the formal parameters. Notice that the name of the function is one word. It's one word. Please take note. It's one word because it's a name. It's a formal name in programming. In programming, the names of things like variables, functions, classes are all one word. There's no space, no special character in between the name. Okay? So please take note of that. Okay. Then we have a much more healthier. So you can see the function definition. So it starts with what? The function data type, which is also called the return type. Then it proceeds with the name of the function. Then it proceeds with the parameters of the function. Okay, it can be 1, it can be 2. You separate them with what? With commas. Usually the parameter always has a data type associated with it. So here, the parameter called side has a data type of what? Int. Okay. Then after you are done with that, remember to have the body of the function. The body. What the function will actually do is called the body of the function. So when you combine these 4 things together, you get the function definition. Any questions? Okay, so I guess that most of us understand the thing. That's very good. Okay. Okay, so okay, so the key differences, like I've told you, is that the function definition has the entire thing, the name, the return type, the body. Sorry, the definition, yes, has the name, the return type, the parameter list, and the body. Okay, whilst the function declaration just has the prototype, what we call the prototype or the header of the function. Okay, so please take note of that. Then the next important thing you need to take note of is that functions have parameters. Okay, so you saw in the definition in the first, in the example, in the first one I shared, there was a function with 1 parameter. And you can have functions with 2 parameters. You can have functions with 0 parameters or with more parameters. What is the purpose of parameters and how can you add them, or why should you add them to functions? Now, what is a function parameter? Okay, so some functions need data. For example, if I want to create a function to calculate the area of a circle, I always need the radius of a circle in order to calculate the area of a circle. Okay, now I can't just create a function and say calculate the area of a circle without giving it data, which is the radius of a circle. So radius will be a parameter I have to create when I'm creating my function. Okay, so the parameters are the variables that are defined within the parentheses of a function. Okay, they are used to what? To pass data. When we say pass data, what we mean is that if you want to give your function any information, you give it that information through the parameters. Okay, they are also used to allow us to create different signatures. There is a feature in programming we call method overload. Okay, so what it does is that it allows us to create multiple methods with the same name. The only difference between them is that they have different parameter lists. Okay, so it gives us some flexibility. Okay, and then it also allows us to break down some complex problems into small manageable parts. It also allows us to do customization. Okay, to customize the behavior of how the function is going to be written. And then it allows us, of course, to communicate with the function. And then it makes it easier to do testing and the debugging of the function in the future. Okay, so let's look at an example of a function parameter. Okay, so over here we create a function called okay, let's look at pencil. Okay, so we marker. So we create a function called print num. Okay, so this function takes one parameter called num, and this parameter should be an integer. Okay, and when it takes the parameter, what does it do? It only prints the value. I told you that when you see cout, it's C++ for out. Okay, output. When you want to do output in C++, you do cout. Okay, so whenever you see cout, it's just print. Okay, print in C++. Okay, so don't fret about it too much. It's not anything. Okay. Then in our main program down here, we want to run this function. So what we do is that we do a function call. We do a function call. Oh, yeah, we do a function call. Now we gave it the number 7. Okay, remember we gave it the number 7. So what it means is that we are passing 7 in. And then what happens is that whenever we call this function, 7 will be given to the number or to print num, and then 7 is going to be printed, and when we are done, we will come back to the next line of this function. Okay, so when we are running, we give 7, we put 7 into n, the variable, and then we pass n to print num. When we pass n to print num, it means 7 is what we are going to print. Then when we are done with that, we come down to the next line and then continue with the rest of our program. Okay, so that's what passing, that's what parameters do in programming. They allow us to give the function some information and then have it do something for us. Okay, so another example shown over here. So in this example too, you are seeing a function with 2 parameters. Okay, the function is called display now. Okay, the parameters are what? N1 and N2. Okay, now with this function called display num, okay, we are seeing that the first position is N1, second position is N2. Now what will happen is that in our program, when we do the function call, and maybe we give this one 2 and we give this one maybe 4, what is happening is that 2 is going to be sent to the first position, and then 4 is going to be sent to the second position. They are going to be sent in the order in which they appear in the function call. I hope you understand me. So what it means is that if you don't provide a second number, Okay, if you don't provide a second number, this program will return an error. It will return an error because you are supposed to every time provide a second number, because the function needs, you are the one who created the function. You said that my function should get 2 numbers. So you always need to provide 2 numbers. I hope you are with me. Hello. I hope you guys, everybody's with me.
Yes, sir. With the 2 numbers, one
Yes.
is an integer and one
Yes.
is a decimal.
Yes.
Okay.
Yes. So it means that you cannot provide 2.1 over here. Okay. You cannot provide 2.1 because this one is supposed to obey this law. The law says that it's an integer. So once you put 2.1, you get an error. Okay. You're supposed to put the required type of information because it's a user-defined function. You are the person who created it. You are supposed to put in the type of information which will make it correct. Okay. Okay. So I suppose that all of us are on the same page. Okay. Let me see if there's more examples down here. Okay. Okay, that's just one example. Okay. Then I think the next section talks about the type of variable. Okay. Sorry, the type of, yes, the type of variable we can use in our programming. Okay. So here there are 2 main, the scope of the variable, sorry. So there are 2 main types of scope we can have in our program. We have what we call global scope variables, and then we have what we call local scope variables. When we say scope of our variables, we are just talking about where in the program your variable can be seen. Okay, so I'll show you an example. So an example, I'll go back here again, and then maybe in this example, if for example we have a variable num1 written over here, and the variable num2 written over here, these, even though this one is num1 and this one is num1, they are 2 different variables because this num1 only exists up here. Okay. And then this num1 only exists down here. It doesn't exist over there. So they are different. The only thing they have in common is that the value you put in the first one will go into the first position, and the value you put in the second one will go into the second position. That's the only common thing we find between the 2 of them. Okay. Now, let me explain. Okay. So when we have a local variable, that is what it simply means. It means that the variable only exists in the place that it has been created. Okay. So let me show you the example. So here we have a variable, 2 variables, one called total, yikes, and then one called average, and then we use total and we use average here. Okay. Now notice that this total only exists up here. Okay, this total only exists up here. Then there is another function down here. Okay, now this function is called main. Remember, this function is called calculate average. This function calls calculate average with some numbers. Then it calls something called total. This total is because it's not created over here, but it's created up here. If you try and call it down here, it will not work because this total is only available up here. This total is local to that particular function up there. Okay, so total in the concept of scope, total is only available over here because this is where it has been created. Okay, this is where it has been created. It has not been created inside this part, so you cannot use it in down here. You can only use it up here. Okay, when it happens like that, we call that local variable. Okay, because this variable total and average are only available up here. They are not available down there. Okay, now there's a case where maybe we may want the variable to be available everywhere. We call that global scope. So global scope means that we create the variable in a place that everybody can see the variable and use the variable. So when in this example, the variable global variable is created up here. And notice that there's a function which starts or begins over here and ends over here. There's another function or second function which begins over here and ends over here. Now, the reason why we are calling this global variable is that you can call it inside this function and it will work. Then also call it inside another function or the next function and it will work. The reason why these ones are working is that this function has been created outside. And so once it's created at the top and it's outside, both functions can use this function, this value or this variable. But if you create this variable inside one of the two, then you cannot stand inside another function and use it or call it. It will be impossible to do that on the function. Okay, so please take note of that idea, or take note of that as well. Okay, so we have two kinds of scope. You have local variable and global scope variable. Any questions about that? Hello? Okay, I think since there are no questions, it means you consent and you understand what is going on. Now let's look at this example. Like I said earlier, parameters are used to share data with the function. Okay, parameters are used to share data with the function. Okay, so an example of the use of parameters or the use of parameter is this function over here, this greet function. So we have this greet function, and this greet function takes two parameters, someone's name and someone's age. Whatever it receives for name, it puts inside the position for name, and what it receives for age, it puts inside the position for age. This is written in Python. So in Python, this is how to do concatenation. Okay. So those of you who I'm saying this before somebody will start now questioning why there's no plus in between the strings. Okay, this one is written in Python. Okay. Now, when you call greet, okay, in the function call, and you enter Alice in the first position, Alice will be given to name. Okay. When you enter 25, 25 will be given to the age. So what it means is that when we are printing, we'll print hello, Alice. You are 25 years old. I hope you understand that. The function data, or the data you are passing to the function, will be given in the order in which they appear. Okay, so the first one must go to the correct position, second one must go to the correct position, and so on and so forth. Okay. 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 And then usually functions have what we call return statements. Now, when you create a function which is a void function, okay, in this example, you see that I told that you can create a function with different data types, but when you create a function with void, what it means is that your function is not going to return anything. Okay, void means you will not return anything. But if you create a function with any of the other data types, like int, like double, like float, like boolean, like string, like character, and all the others, you must always have this statement: return something. You must return something which is the same type as the data type over here. Okay, so for example, over here, because we said that add is an integer function, we make sure that C is an integer as well. If you add two integers, you get an integer, and then you put inside C, and then we return C. I hope you understand the logic for that one too as well. Okay, so return statements are used when you use any of the data types, but when you use void, you don't use any return inside the function. So let's look at an example, a full-scale example over here very quickly. Okay, so in this program, let's check this program. It's in C++, and you are seeing very simply a program which has a function called add. All the function does that we are adding two numbers, A and B, okay? And then we add those two numbers, and then we return it to whoever is calling us. Okay, so you need to call add. Like I said earlier, function call is a line which will call their function. Just like your children, they'll be in their room until you call their names, Kwesi, Ama, before they come. So when you create the function, your function will be there. It will lie dormant until you call it. And just like your children, you can call them as many times as you want. Every time you want to call them, you just write the name, and then you give it something. You write the name and you give it a value. Okay, so let's look at our function. So we have a second function called main. I've already told that in C++, main is required. It's a function that you must always have. Okay, so we create a variable called sum. Okay, and then we set sum equal to add 100, 78. What happens is that 100 is put inside the first position, and 78 is put inside the second position. Okay, that's what happens. So wherever we see A, we should put 100. Wherever we see B, we should put what? 78. And then what does, because it's a function call, so we'll go and put it over there, and then we'll run the function. So running the function means you do A plus B, which is what? 100 plus 78. We get 178. And then we put that 178 inside the variable sum. So now remember, sum contains 178 because we have to return that answer to sum. Okay, so sum contains 178, and then that is what we print over here. So we print 178, and then we main itself returns 0. So 0 means exit. Okay, I hope it's understandable. Who did not understand what just happened? Okay, most people are signaling. I just guess most of you are just tired, but bear with us. Okay, bear with us. They will post the video links so that you can go and watch the class later on. Okay, they are here on the call recording and then taking notes of all your questions. Okay, so they will help you with that. Okay, so this part of the slide, this part of the booklet helps you to understand how the data is sent from the main method to the function that is called. Okay,
You can't hear anything.
You can't hear me?
I can't see anything.
Hello, you can't hear me? Hello, you can't
Sure,
hear
we can
me?
hear you.
So why
We can hear you.
saying you can't hear anything? Is he referring to me?
Maybe it's his network.
My dear friend, please check your network, okay? Hello, my dear friend, who said you can't hear me? Please check your network. Okay, so whenever we see the function call, we will go and run the function, the statements inside the function. The first value is given to the first parameter, and second value to the second parameter, and so on and so forth. And then the values the code is run by adding the two values, and then the answer, or adding the two values, and then we return to where you were called. Okay, so returning means that when you have an answer of A plus B, come and give it to Sam, and then continue with the rest of the code inside me. Okay, so you can do this as many times as you want in the program that you have written. Okay, you are not only allowed to do it once, you can do it as many times as you want. Okay. Okay. So the return type is very good because the return type helps you to give us a particular value. The return types help you to handle the data properly. The return type will also facilitate error handling. Okay, because once you say that once you say that the function is an integer function, we are expecting integers, no decimals. Once you say it's a string, we are expecting something with quotes, not something without quotes. Okay, so it's very important. And then the function, the return type also enforces safety. Okay, the return type also guides the way the program is flowing. Okay, now there are different types of function return types. The function parameters. Okay, we have what we call the required parameters. When we say required parameters, what we're saying is that as for them, once you use required parameters, you are supposed to have them in the program. Okay, then we have what we call the default parameters. Default parameters means that we can have the optional because the data will always be provided. Okay, so an example is having something like this. Maybe you have a function, and then the function is called add. Okay, then instead of having A alone, you see, you put something already in A. Okay, so something like this. An example of this is what we call a default parameter. It means we already have something in A. So in the function call, you can just call add with only one value. Okay, if you call add with one value, this will work because A is already there. 12 will always go into what? B, the one which is not there. Okay, we call that default parameters. Okay, we just want to expose you to the ideas so that when you begin to learn the programming, you understand why the program is behaving the way it's behaving. Okay, so that is what that means. It's called default parameters. Okay, then required parameters, we don't provide the examples. The examples you saw earlier. Okay, all of these examples, they're examples of required parameters because we don't provide the value of A and B, so that you have to always enter it by yourself. Okay, so that's what we call required parameters. Okay, then let's do unit 4, section 4.
Hello?
Yes, sir. Yes, sir. I'm listening. Hello. So somebody was asking a question, right? No.
The person was having a network challenge, so it was
Okay.
just
I thought they were asking a question. Okay. And now here I will just briefly explain what it does, but I don't think there's an example to show you. So I'll briefly explain what it does, and then it's just you need to just read and then be conversant with the idea. Now, there are some functions we write which keep they work like loops, okay, but they are not loops, okay. They keep repeating something over and over and over for some number of times. We call them recursive functions, okay. Recursion and recursive functions, okay. So the function, we call it recursive function, okay. The idea is called recursion. Recursion means that you want to write a program which repeats something over and over without using loops, okay. Here the idea is to use a function by calling the function several times on smaller values of itself, okay. So in order to do recursion, you need to use some key things. One of the key things, or one of the key places that recursion can be used is what? To do something called divide and conquer. Okay, it's an idea of in programming where we break a problem down into smaller chunks and we try to solve the smaller chunks. Okay, it's called divide and conquer. Then abstraction and modularity. Okay, and in that particular type of design, we are trying to break down the problem into smaller sub-problems and then hide the way the problem is being solved. And then recursion also allows us to do some formulation in programming, which allows us to maybe represent the way a problem is solved very simply. Like I said, recursive programs can do things like how do you call it? Loops. So instead of using loops, which are computationally expensive, you can use recursion, which is very easy. Okay. And then, like I said, you can also use recursion to solve very complex problems earlier, right? So an example where recursion is used is in something called factorial. Okay, I don't know, most of us who did elective maths or core maths in secondary school, you probably, I think some of you are also secondary school teachers and GSS teachers. You've seen the factorial, okay? Factorial, those of you who have forgotten a little bit, if you remember your secondary school days, you've seen something like this 5 factorial, which means 4 times, where was I starting? What was I thinking? 5 factorial, which 5 factorial, which means 5 times 4 times 3 times 2 times 1. Okay, so typically we would use loops to do this kind of thing. Okay, but loops very expensive in programming. Okay, so we can use recursion to try and solve a problem like this by building a small function which will call itself on smaller versions of itself. Okay, so an example would be something like this. Int maybe okay, so int maybe fact. Okay, then maybe we'll take an integer x. Okay, so if we know that the factorial of 0 is, the factorial of 0 is, I think, 1. Okay, so we return 1. Okay, else we return I think we return the number, which is x. Okay, the number times smaller versions of itself. So fact. So fact. Oh, I didn't gauge the space well, but we return the number in smaller versions of itself. Okay, so x minus 1. Okay, so that's basically how to cut. It's a very easy idea when you know exactly what you are doing. Okay, but you don't have to worry yourself too much about it for now. Just to know that there's an idea like that and how it's useful for or in your future programming journey. Okay. Okay, so you can use it also in the Fibonacci series, sequence or series, and we can also use it in the binary search. Okay, Very easy idea. Okay. So usually in recursion, what we do is that we identify something called a base case. The base case is a primary answer. So in the case of the factorial of 0 always 1. Okay. And then the case of after finding the base case, you need to have a way to come or to reduce the problem from the current state to the base case. So in the case of the factorial, every time we are trying to reduce the problem by 1, okay, until we get a small version of the problem. Okay. Hello, are we all following? Yeah, I know at this point most of you are very tired, so you're probably not really following much, but please try and pay attention to what is happening. Okay. Then the next section, we're looking at the two main classes of functions. We have the standard library functions. Okay, so we're looking at the standard library functions here. We're looking at all the functions that come with your programming language. Okay, so the standard library functions are the functions that come with your programming language. They come when you download Java or you download Python or you download C++ or C or any of those programming languages. They come with certain functions built into them already. So those ones are called the standard library functions. Okay, so they are useful for what? Operations on strings. They are also useful for mathematics. They are also useful for dates. They are useful for file operations. They are useful for what? Output, input, and output operations, and so many other things. In fact, there are lots of uses for standard library functions all over the place. Okay, and they contain some data structures like lists, arrays, dictionaries, sets. They are also useful for network connectivity. Okay, so you can use them for network connection issues like HTTP protocols, HTTPS protocols, file server protocols, and the rest. You can also use them for email processing. You can also use them for signals to the OS. Okay, you can, like for example, return 0 is a signal to the OS to stop the current thread and move, maybe hand over control to the processor or something. So all of those things come with your programming language. They are built already for you. Now, the reason why they come is that they make it easier for you to be productive. Okay, because they've been built already. You don't have to build them into your programming language again. Okay, now what you have to do as a programmer is that you have to go online or get the documentation and read it. You have to also use the functions, right? Very easy. You have to use the built-in functions and modify them or use them. You have to use them efficiently so that it helps you in your programming. Okay, so here they show you an example of how things have changed over the years. Okay, so in this example, in this first example, you see how we used to write C++. Okay, if you wanted to do input or output, for example, you want to print hello world in C++. Before a few years ago, you have to write this long line to print hello world. Okay, just hello world in C++. Okay, now you can simplify the entire process by using something called namespace. Okay, so okay, let me write it alongside this one so it makes it easier to see. Okay, so currently, by simply typing using namespace, okay, std semicolon, by simply typing this one line, you don't need all of this. Okay, you don't need to add this one. You don't need to add this one. Oh, sorry. Okay, you don't need to add this one, std over here. By simply doing the using namespace std semicolon. You don't need to add that std scope resolution over here. Okay, that's a simple way to write your programs and make it look clean and simple. And that is what they are explaining in the, that's what we are trying to explain in the code you are seeing in the examples that you see down here. Okay. Then the final session in that, okay, the final session in that book. Okay, I think that's the final session. Wow. Okay, so we've already talked about that. So the final session is what we just discussed, the standard library functions. So use them so that it makes your coding or your programming easy. Okay, so I'll take questions here. You can now ask me questions which are out of the scope of our class. Okay, but please, I'll be happy if you ask me questions within the scope of the class. Okay, questions concerning switch and the rest, please, you have to direct them to the coordinators. Okay, thank you very much. Okay, I have tried to get everything in there for you. So that's unit 4. Next time we meet, I'll try and go over unit 5 and 6 for you, so that at least you have a broad scope of what is in the entire document. I'll share the 5 and 6 with the course rep when they contact me. Okay, any questions for me, please? Please keep it within the scope of our lectures today, and then if possible. Okay, and there was a lady who asked a question about exams. Can you come again? Let me see if I can answer that one. If not, they will answer it later on.
Okay, so please, I was just asking if the questions will cover units 1 to 6 for the exams.
Oh, I think you do quizzes, right? You do quiz 1 and quiz 2, right?
Yes.
So I think quiz 1 usually covers 1 to 3, and then quiz 2 covers everything from 1 to 6. That's what I think they normally do. Okay, but I could be wrong. Okay, I could be wrong. So we'll give you all the material. I'll go over everything with you. I'll try and explain, because I can explain it. It's not anything difficult I cannot explain. So I'll explain it as best as I can. And just try and study the material, but don't be picky about what to learn and what not to learn. Okay.
Okay, thank you.
You're welcome. Yes, there's a gentleman who wanted to ask a question.
Hello, sir.
Yes, sir.
Please, I was concerned about the model or the material you're using to teach. You were talking about one that was your own. Kindly add that one.
The
slide. Yeah.
I did explain that last
Can
week
you add that
and
one
the week before. Pardon?
I was saying that if you could kindly add that one to yours to the one here.
No.
Oh, sir.
I want us all to use the same material. Okay, my coordinator, the other class, and myself, we are all using the same material. But because I'm doing online, so I usually prepare slides to make it easier to teach. Okay, because you can see how the book is very big, and it keeps running back and forth. But with the slide, it's easier. Just that some of your friends are seeing the slides, seeing the book, and seeing the disconnection. So I don't want you to be disconnected from the material. Okay, just use the material. That's all. Hello. Please stop. Who's that?
No. I'm actually walking. I just passed by some people who are. Sorry,
okay.
Sir. Sir, please. The reason why I'm saying this is that we are not just learning this for exam's sake. We also want to practice it when we go further, or let's say on a personal basis, right? We want to put whatever you are learning into practice. So if we have an extensive material that will help us, I believe
it's just
it shouldn't be
slides. It's not about extensive. It being extensive. I how do you call it? I summarize the material, so it's not even extensive. It's my own interpretation of the material with some examples I added. Okay, so it's not that it's more than what you have. Just that I don't. You see, there are many people who are on the call who maybe just join the call and not pay attention. So sometimes, when they're looking at what they are holding and what I'm sharing on the slides, they are not following what is happening. Okay, so but I want you to now follow and then see that I'm just doing the what is in the material, or it's not anything. Okay, it's not anything. We are the ones who teach the material, so don't worry about it. We'll give you everything that you need to know, and then even if we need to do examples, I can give you. You see, today because I'm doing from the book, notice how I took my time to annotate on the PDF. Okay, I can do that. I got my tablet up and then I did all of those things for you. I could have just walked through without doing that. Okay, but I can do it for you. It's not anything difficult. Okay, so don't worry. I'll walk you through the material. You understand. If you need to learn further for maybe yourself or personally, like I said, there are resources out there. There are nice books out there. They are very simple, and maybe YouTube videos also, which can explain different concepts or ideas. But I'm sure you do another course in programming proper, which will now go and explain and maybe how to do the actual coding. Okay. Hello.
Hello, sir.
Okay.
Yeah, we perfectly understand what you are saying. It's just a plea that you add up your slides so that we'll just use that one to and then guide ourselves through it. It's not like we are saying we are going to put away the main book, but we need yours as well. We are just pleading.
Okay, you have heard you. I'll talk to my coordinator. Okay. The other class is not using it. I don't want to cause any problems. Okay, I'll talk to my coordinator first. Yes.
So my problem is about the striking difference, the striking distinction between the the system function and what the user defined function. How you can easily identify and differentiate between them.
Between a system, the ones which are system functions, the system, the library functions, standard library functions, right?
Yeah,
Okay, so those ones are built into the programming language itself. Okay, let me join with my laptop and show you something. Okay, I want to show you something on the laptop.
Okay. I understand it by definition, but I want to see if I see it, how I'll be able to know.
Oh, you know. Right. So standard library functions, they come with the programming language. Like I said, they come with the programming language. Okay. They are built into the programming language, so you don't have to worry about them. Let's see. Share, allow. Okay. Okay. Let me show you an example. Allow to share screen. Allow to share window. Okay, share screen. Okay. 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 Are you seeing my screen? Or I think it was not successful. Okay. Okay. Let me see. Okay, this one. Okay, so you guys are seeing that one, right?
No, sir.
Oh, really? Yikes. Well, it is showing here.
Hey, I don't know why, but it's sharing. I can see it though.
But it's
Okay,
not
it's now
reflecting here.
appearing.
Oh, so even if you can give us a verbal description, maybe we can comprehend.
But
Yes,
I can see
that's
the
what I
screen.
said. That, for example, if you download Java
Oh,
or you
okay.
download,
Then
for
let.
example, if you
Okay, sir.
download,
Then please
I
wait
think
and
it's showing
let's
now.
exit and join again because me I still can't see.
so if you
It's
It's
showing a
showing,
download,
screen. It's showing.
how do you call it?
Please, it's showing now.
Okay, so like I was saying earlier, if you download Python, okay, you will notice that um, you can do things like print, even though you didn't write any print into the Python program, into the Python environment. Okay, you can do print. So
Yes,
let
sir.
me do a test.py. Okay, everybody can see that one on the screen, right? So for example, you can
Yes,
do
sir.
print,
Yes, sir.
and then you can do hello world. We did not write anything into Python earlier. You just got Python working, and when the first time you got Python working and you wrote Python run, and then Python returned an answer in the console. So you can see the terminal output over here. It's still running. I think I have an issue here. Okay, it's still running. You can see the response down there. Okay, so this print is an example of a built-in Python function. Okay, so you can see that. It's a standard library function. It's built into Python, print. You didn't write it. Somebody, the person who designed the Python interpreter, wrote it into the standard library so that when I download it on my laptop here in Ghana and I write print and I put the hello world in there, when I run it, you see the output in the terminal. Okay, sorry, in the console.
Sir.
I hope
so. I'm getting
not too big for you to see.
Hello, sir.
Yes, sir.
Hello, sir. Okay, it means
yes, sir.
alert in JavaScript is also a built-in function. Alert.
Yes, so it's built into the Python library. You don't have to, you don't have to create it or do anything. All you need to know is the name. Once you know the name and how to use it, you are good to go. You can use it. Okay, but the user-defined functions, you create it yourself. So an example is to have something like in Python, you can have something like this. Let's say we have A and B, and then in Python you do return A plus B. Okay. So in Python, something like this is user-defined. This one, this second one, this one is user-defined. I created it. If you download Python on your laptop and you try to call add, nothing will happen because you have not created any add. You have to create it like the way I am also creating it here on my laptop before you can now use add. Okay, if I want to use it, I have to now maybe call it with a number or something like that. Okay. If I want to see the results, I have to print the results still. Okay. 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 So you hope you understand that. Hope you understand the idea.
Yes, sir. Yes, sir. I've got it.
Okay, so user-defined functions, you the user, creates it, but standard library function, it comes with your programming language. Okay. Okay. Any questions? Any other questions?
Sir,
Hello.
please, sir.
Can you hear me?
Yes, sir. Sir, I
Our
was saying
time will
that.
be up very soon.
Yes. Hello, sir. Hello, sir.
Yeah, I'm here. I'm listening. I'm listening.
Yes, I was saying that write or alert function is also built in JavaScript, or
Yes. It's a console. It's a console. Yes. So yes, that's an example of a user. It's an example of a standard library function. Yeah.
Thank you, sir.
Thank you. The mathematical functions like pi, maybe tanh, square root, all those ones are examples of standard library functions, because they don't want you to concern yourself too much about how you write a program to do square root. So they've already built the square root function for you. All you need to do is to call the square root function, give it a number, it will return an answer. That's all. So I think yes, sir.
Last week recorded lectures have not been shared. I don't know whether I'm the only person who didn't get access to it.
Oh, I have already told you or addressed this matter. They are on the call, okay? The switch coordinators are on the call. They are monitoring our call. In fact, they are recording the call.
So for last week, shared.
Yes, they will share it. They will share it. I'm not the one who is recording. Mr. Osman.
Yes, please.
I'm not the one recording. Somebody is recording, so the person will share it.
Okay.
Yes, somebody. I'm not the one recording. Okay, somebody is recording. In fact, there are lots of people on the call monitoring the call. Okay, so they will make sure that you get your recording.
Hello, sir.
Like I said, we are pleading to make it available before we come for the next class. You know, today.
Okay. Noted. The person is on the call. They will listen. They will heed your plea. Okay.
Okay. Thank you.
No problem.
Hello, sir.
Yes. One final question.
Yeah,
Yes, sir.
Yeah. I want to ask you this question. Right now, after this course, BEd Information Technology, if I go on to do maybe MSc, MPhil, and then proceed to PhD, can I become a lecturer, or that one you have to switch?
Please come. This one is not it's a private question, so you ask me privately, okay?
Okay, sir.
Okay, thank you. The call is being recorded, okay? So you ask me private things privately, not on the call, okay? Okay, so thank you very much. Enjoy your evening. I'll see you guys next week. I hope you are. Please, course rep, remember to send me the message so that I can share the document with you. Okay.
Okay, sure.
Thank you. Yes. Thank you. Bye-bye.
Bye.